does not react.
And before you look at that, if you have, so you realize A minus square root of B is the conjugate surd of A plus square root of B. So in this case, when you rationalize using that, you multiply the denominator and numerator by the conjugate surd of the denominator. So to rationalize here, you have to multiply the numerator and denominator. So to rationalize, multiply the numerator and the denominator by the conjugate surd, You'll have to multiply both the numerator and the conjugate surd of the denominator. You'll have to multiply by that conjugate surd. So in our solutions, this is what we are going to get in 1, 3 square root of 5 minus 1. And since I've told you this is what you multiply the numerator and the denominator, you'll come and say 3 square root of 5 plus 1, the conjugate surd of the denominator. The conjugate surd of the denominator is multiplied by both the numerator and the denominator. So how does that work? You open the brackets. Then here you come, open the bracket, square root of 5 times square root of 5, you'll have square root of 5 times square root of 5 minus plus square root of 5 minus square root of 5 plus 1. Let's look at what will happen. This square root of 5 cancels with that square root of 5. Square root of 5 times 5 is square root of 25. So this will work to 3 square root of 5 plus 3 over square root of 25 plus 1. So learn how does that come, what does that come to? Square root of 25 is 5. So it will be square root of 3 square root of 5 plus 3 over 5 plus 1 over 5 plus 1. It works to 3 square root of 5 plus 1 over 6. That is the simplified form by rationalizing the denominator by multiplying by the conjugate surd of the denominator. So first of all, you get the conjugate surd. Then you multiply it by both the numerator and denominator. That is rationalizing using what? Using the conjugate surd, or we simply say rationalizing the denominator. We shall look at the second example where we have 4. We shall come to 2. Number 2. You are given 4 over 6 minus square root of 5. The first thing is to get the conjugate surd of this. The conjugate surd of the denominator is of 6 subtract square root of 5 is 6 plus square root of 5. So you'll go straight to multiplying by each. So this will come to 4 into 6 square root of 5 over, when you do this you are rationalizing, over 6 minus square root of 5 into 6 plus square root of 5. So you simplify. 4 times 6 is 24. 4 times 6 is 24. 4 times square root of 5 is 4 square root of 5. We come down. 6 times 6 is 36. 6 times 6 is 36. Then we have 6 square root of 5 minus 6 square root of 5 plus 6 square root of 5. You start with plus, then minus 6 square root of 5. Then you finish up with the square root of 5. Square root of 5 times square root of 5. Let's simplify. The denominator remains the same. 24 plus 4 square root of 5 over this and this cancel, plus 36 minus square root of 25. Square root of 5 times square root of 5 is square root of 25. So you'll have 24 plus lana 4 square root of 5 over 36 minus 5. 36 minus 5. This will work to 24 plus 4 square root of 5 lana over 31. That gives us our answer. That gives us our answer. So in such a case, you look for the conjugate surd of the denominator and multiply it both by the numerator and the denominator. So having done that, it will be time for an assignment. So before I go to the assignment, know what a conjugate surd looks like. The sign changes there. If it was positive, it becomes negative. A minus B is the conjugate surd of A plus square root of B. So learner, that was the assignment, rationalize the denominator. You saw how we went about. So A, 1 over square root of 2, B, square root of 2 plus 1 over square root of 7, C, 1 over square root of 3 plus 1, D, square root of 2 over square root of 11 plus 4 square root of 10. So here you need a conjugate surd. In these two, you need a conjugate surd. These ones you multiply, just multiply this by square root of 3 over square root of 3. Multiply here, square root of 7, square root of 7. But in these two, you need the conjugate surd. So thank you very much for the audience.
Welcome to Manifested Publishers.
Hello, boys and girls. Welcome to Manifested e-learning platform. I am Teacher Purity and I will be teaching you Christian religious education activities for grade 4. So welcome to this lesson. Now, allow me to welcome you to grade 4. It is a new class. Most of you are excited to be in this new class because you know you are going to explore a lot. Now, let's talk about Christian religious education as a subject in this class. Christian religious education is a subject which helps us to understand different things that are related to Christianity. For example, knowing about God, how you are supposed to live with others, how some of the things you are supposed to do, they guide us on what we are supposed to do. In grade 4, we are going to learn about creation. We shall talk about self-awareness. We shall also learn Bible stories and many, many more. So it is my hope that all of you are going to enjoy learning CRE, especially for this class. Now, the very first topic that we are going to start with is about creation. And under creation, we shall start learning about self-awareness. Under self-awareness, we shall talk about my name makes me special. Let's remind ourselves the meaning of the word creation. Creation is bringing something that was not in existence to exist. You are creating something that was not there before. That is what you mean by the word creation. And for this case, you are talking about God's creation, whatever God created. Then we have the word self-awareness. Self means yourself. We are talking about yourself. And awareness is to understand or know something. So the word self-awareness means knowing more about yourself. You want to know more about yourself, who you are, what you like doing, who created you, and many, many more things about yourself. Now, self-awareness is knowing oneself much better. Self-awareness is knowing yourself better. Is knowing yourself better. And we are talking about my name makes me special. Now, all of us or each of us has a name. Why are you given a name? There is no single person who doesn't have a name. There's no a person called nameless. No, at least each of us has a name. And a name is something that helps people to easily identify you, who you are. It is just an identification of you, of who you are. So we all have a name. Remember that I said a name helps us to be identified by other people. And when a person wants to talk to you or wants to call you, he or she will call you by your name. For example, I am Purity and another person is Mary. So Mary has a name. I also have my name. When a person wants to talk to me, he or she will call me by my name. So that means that people call me, let's say people call me, you are talking about yourself, people call me by my name. People call me by my name. And all children must have names. Remember that it is also one of the rights of children. A child has a right to be given a name. That's why everyone, after you are born, you are given a name. So people call me by my name. Why do people call you by your name? Even God knows you by name. So God created us in his own image and therefore he knows us by our names. So God also knows me by name. So God knows my name. God knows my name. And because God knows your name or my name, He calls you by your name. When God wants to talk to you, He will just call you, Mary, I want to send you to maybe a place. God wants you to send you for a mission, maybe to preach, to sing, to dance, or even teach other children. So God knows my name. He therefore calls me by my name. He calls me by my name. God knows my name. He calls me by my name. If you can remember the story of Samuel, God just called Samuel by his name. He called him Samuel, Samuel. He called Samuel 4 times, but Samuel responded the 4th time. That means that God knows each and every one of us name. So God knows my name. He calls me by my name. Therefore, your name makes you special. So my name makes me special to God. My name makes me special to God. So my name makes me special to God. You are special in your own way before God. And God easily identifies you by your name. So that is all about my name makes me special. We've talked about self-awareness, which is knowing yourself better. And we all have a name. Remember, a name helps one to be identified easily by other people. And people call me by my name. That is why all of us have a name. And it is also a right. You are supposed to have, it is your right for you to be given a name. That is why when you are born, you are given a name. Then God knows my name. He calls me by my name. God knows you by your name. And therefore, when He wants to call you, He'll just call you by your name. You remember the story of Samuel? I've told you about it. God just called him by his name. Then lastly, my name makes me special to God. Your name makes you special before God. God knows that this is Shayla, this is Joy, this is Joanne, this is John, and He is able to know how special you are before Him. Now, I want to give you some work about what I have taught on self-awareness and my name makes me special. So take your exercise book and copy the questions. Now, the exercise is here. Only 3 questions. The instruction says answer the following questions. Answer the following questions. Number 1, what is your name? So you are going to write your name in the blank space provided. Question 2, how is your name different from your friend's name? How is your name different from your friend's name? How is your name different from your friend's name? So you write there what you think. Then question 3, why should people call you by your name? Why should the people call you by your name and not another person's name? You also write your answer in the blank space provided. So thanks for being good listeners. Hope to see you in the next lesson.
Welcome to Manifested Publishers.
Hi learners, welcome to Manifested e-learning platform. I am Teacher Purity. So we are going to learn hygiene and nutrition activities, and we had started on a new topic, the use of improvised materials for cleaning utensils. So today we are going to learn the things that we use to clean utensils. But before that, let's remind ourselves of what we discussed during our previous lesson. Now, in our previous lesson, we learned the types of dirt found on utensils. So let's go through the types of dirt found on utensils before we learn the things we use to clean utensils. So types of dirt found on utensils. The types of dirt found on utensils. The utensils we use at home, after you've used them, they always become dirty, and they are dirtified by different types of dirt. So we say that the first type of dirt, we call it milky dirt. Milky dirt. Milky dirt comes from the word milk. The utensils you've used to serve tea, the utensils you've used to drink milk or yogurt will have milky dirt. Then we had another type of dirt we call grease dirt. Now, grease dirt are the dirt found on utensils that have been used at home, and most grease dirt are caused by eating oily foods. For example, if you prepare your fish and put a lot of oil in the fish, you will have oil dirt on your utensils, or even meat or fried eggs. And lastly, we have another type of dirt called starch. Starch dirt. Starch dirt are the remains of food that we have eaten that always remain on a plate. We call them starch dirt. When you eat ugali, the ugali that remains on the plate, vegetables, we call them starch dirt. So these are the types of dirt found on utensils: milky dirt, grease dirt, starch dirt. So for this lesson, I want us to learn the things that we use to clean utensils. The things you'll need for you to clean milky dirt, grease dirt, or starch dirt on utensils. So, things used to clean utensils. Things used to clean utensils. We are supposed to wash our utensils back at home every time you use them, because dirty utensils attract insects such as cockroaches, or they can even bring germs. And remember, when you serve food from dirty utensils, you can fall sick. So that is why you are supposed to clean your utensils at home. First, to keep away germs, and second, to keep away pests such as cockroaches. Now I want to find out what are the things that we will require for us to be able to clean the utensils at home. Now the things used to clean utensils. First, for you to be able to clean utensils, you need clean water. So, clean water. Now the clean water, you are going to use it to wash the utensils and then rinse them. Then you will also need soap. We need soap. Soap will help us to remove dirt from utensils. You also need a sponge or sponge. You will need a sponge to clean utensils. Now, if you don't have a sponge, you can use a small piece of sisal fiber or a piece of cloth to wash your utensils. Then, number 4, you will need basins or a basin. You will need basins. Now you are going to put your water in a basin. For sufurias that have stains, you will require steel wire. You will require steel wire. So these are the main materials that we require for us to be able to clean utensils. First, you need clean water. You will also need soap, then sponge, and if you don't have a sponge, you can use a sisal fiber or a clean piece of cloth. Then we have basins where you are going to put your water when cleaning the utensils. And lastly, we have steel wire. The steel wire helps to scrub sticky stains from sufurias. Now we have the utensils that are oily, the ones you've used to serve yourself with meat or fish. Now the oily utensils, you can soak them in warm soapy water. Warm soapy water is used to soak oily utensils. Why? When you soak oily utensils in warm soapy water, it will help the oil to come out easily. So these are the main things that we use when cleaning utensils. First, we need clean water, soap, sponge, basins, and steel wire. The materials you require for you to be able to remove the different types of dirt that are found on utensils. So make sure at home when you are washing your utensils, you have clean water with you, have soap, sponge or sisal fiber or a piece of cloth, you have a basin or a steel wire. Now in our next lesson, we shall discuss how we can improvise these materials used to clean utensils. If you don't have soap, what can you use to clean your utensils? If you do not have a sponge, what will you use? If you don't have a steel wire, what can you use to scrub the stains from utensils? That is what we shall discuss in our next lesson. Meanwhile, copy the question that I'm going to give you on the blackboard and make sure that you are answering it. So write down the materials used to clean utensils. You write down the materials that you require when cleaning utensils in the blank spaces number 1, 2, 3, and 4. So thank you for attending to the lesson. Hope to see you next time.
Welcome to Manifested Publishers.
Hello viewers, my name is Geoffrey Omondi. In the last class, I introduced you to Vector 2. And in that class, we were able to learn, first of all, the concepts. We were able to learn the concept of a 2 and 3 dimensional Cartesian plane. We were also able to learn at what we call column and position vectors in 3-dimensional Cartesian plane. Column and position vectors in 3-dimensional plane. So this is what we learned in the last class. I now want us to continue and learn something new for today. Now today, I want us to learn the concept of unit vectors I, J, and K. So vector I, J, and vector K in a 3-dimension Cartesian plane. And we'll also learn as well what we call the magnitude of a 3-column vector. A 3-column vector. So vector in a 3-dimension Cartesian plane. So we'll also learn about its magnitude. So I want us to start with the concept of the I, j, and k, which are unit vectors in a 3-dimension Cartesian plane. So in the last class, I showed you how we can draw a 3-dimensional Cartesian plane like that. I told you that we start with the x-axis that way, and then we go to the y-axis. Y-axis is there. And then this one is actually the z-axis, Now, consider a 3-dimensional Cartesian plane like that. And let's say we have 1 unit towards every direction. 1 unit towards the x-axis, 1 unit towards the y-axis, and also 1 unit towards the z-axis. Now, so this would be 1 unit, 1 unit, and 1 unit. Now, we can represent the unit vector towards the x unit by what we call I. So this will be vector I. We can still represent 1 unit towards the y-axis by small j like that, vector j, and still represent 1 unit towards the z-axis by small vector k that way. Now, if we are talking of 1 unit, it means the coordinates at x after 1 unit will be, the coordinates here will be, x is 1, y coordinates on x unit is 0, and z coordinates in x units is also 0. So we mean we will have 0.1, 0, 0. 1 unit here towards the y-axis would mean that the x values on the y-axis are 0, followed by the y unit, which is 1, followed by the z unit, which is 0. Now, in the same spirit, 1 unit from the origin towards z will have x here being 0, y is 0, but z is 1. Now, using these 3 vectors, therefore, we can represent the 3 points. In other words, on x-axis, we can say that we have point 1, 0, 0, like that. And this is actually 1, 0, 0, I. On the y-axis, so this is the x-axis. On the y-axis, we can say that we have point 0, 1, 0, like that. And then on the z-axis, we can say we have point 0, 0, 1, that way. Now, looking at these 3, therefore, we can say that I correspond to value of the x-axis. Therefore, we can say that we have 1I, which is I, there. So if you were to take a point, say here, that is presented by 1 unit of x-axis, 1 unit of z-axis, and 1 unit of y-axis, then we can say that we have 1I this way, plus 1j, and finally plus 1k. In this case, we are talking of j, and we are also talking of k, that way. So I want us to take an example so that we can understand all this clearly. Now, we are taking example from KLB. So this is example. We are taking example from KLB. So that is example. Suppose you're given vector OE, and we are told that vector OE is given by the 3-dimension or 3 coordinates like that. Then you can be asked to write this vector in terms of I, j, and k. Now, when you are told this, it is important to know that I stands for x units, 5 stand for y units, and 4 stand for z units. Now, like I've told you before, on the x units, it's normally represented by vector I. On the y units, it's normally represented by vector j. And on the z units, it's normally represented by vector k. So taking this, if you're told to write vector OE 3, 5, 4 in terms of I, j, and k, you'll simply say that we have 3, but 3 corresponds to I because 3 is on the x-axis. So that would be 3i plus 5, which responds to j, like that, plus 4, which responds to k, like that. So when we look at this, by writing this, it will mean that we have finally written OE 3, 5, 4 in terms of I, j, and k. Let's look at more examples. Let us look at more examples. Let us look at more examples. Let us look at more examples. You can be asked to express. Can be asked to express. So this is example 2. Example 2 can be asked to express vector. Express the vector 5, -2, 7 in terms of unit vectors I, j, and k. Now, bearing in mind what we've already done, we know that 5 will correspond to I, so you'll simply say this is 5 vector I plus -2 vector j. But since we have plus and minus at the same place, normally positive and negative equal negative. So we'll write minus that way. And then finally, plus 7 vector j. So in that case, you shall have expressed what is expected of you. We can look at further examples where we can see. Suppose we want to add these vectors in terms of I and j. Suppose we want to subtract them. Suppose we want to multiply by scalar. What do we do? So let us look at other examples. Example 3. Example 3. Let us look at other examples. And we are looking at example 3. So picking from this, you can be given an example like this. If vector A is equal to 2i plus 2j plus 5k, and vector B is given by 3i minus 4j plus 7k. Find question A, vector A plus vector B. Question B, find vector 3A plus vector 2B. So I want us to start with the first one A. I want us to start with the first one A. I want us to start with the first one A. I want us to start with the first one A. Let me just transfer it here. A, vector A plus vector B. Now, there's something we already know. When we were working, we saw how we can move from column 2 in terms of I, j, and k. Sorry, this must have been K, I, J, and K. Then it means that from that we can write A in terms of column vector. So A in that case will be 2, 2, and 5. That would be A in terms of column vector, plus B in column vector would be 3, negative 4, and 7, that way. So we can add these two column vectors, a concept we've already learned, such that we can say 2 plus 3 would give us 5. 2 plus minus 4, that is the same as 2 minus 4, which will give us minus 2. And then 5 plus 7, which will give us 12. Now, having now this column vector answer, we can now rewrite this column vector answer in terms of I, J, and K. In which instance, we'll start with 5. But 5 is on the x coordinate and therefore corresponds to 5 is displacement on the x coordinate and therefore corresponds to I. So it will be 5 vector I that way. Minus 2, which is displacement on the y-axis and therefore corresponds to vector J. And then plus 12, which corresponds to vector K. Now, learners, I know some of us wonder, why do we use negative and positive? We simply pick the signs before each number. Like in this case, 5 is a positive one, so we are using 5. 2 is a negative one, so we are introducing this negative. And 12 is positive, so we are introducing that positive. So this basically will be vector A plus vector B. I want us to try the second one. Question B. You asked to work out 3 vector A plus 2 vector B. The idea is still the same. We have to write vector A and vector B in terms of column vectors. And in this case now you'll have the scalar positive 3 multiplied by vector A, which in that case we've already just worked it out. It will be 2, 2, 5 plus 2, these two here, multiplied by vector B, which is 3, which is the coefficient of vector I, minus 4, which is the coefficient of vector J, and positive 7, which is the coefficient of vector K. So working on this, we already have learned, this is a knowledge we already have, multiplying vectors by scalar. So in this case, we'll have 3 times 2, giving us 6. 3 times 2 again, giving us another 6. And 3 times 5, giving us 15. Plus, we'll have 2 times 3, giving us 6. 2 times minus 4 gives us minus 8. And then 2 times 7 gives us 14. So we can add that way. And then from this point, we can now say 6 plus 6 should be 12. 6 plus minus 8 is the same as saying 6 minus 8, which should be minus 2. And then 15 plus 14, which is actually 29. So working with this information, this is column vector, we can now easily rewrite this in terms of I, J, and K. In which instance, we'll now be saying we have 12I minus 2J plus 29K. So when we work with that, that is actually how we write vectors in terms of I, J, and K. So I think up to that point, I will leave for you a little assignment that you can work on so that you practice more and more on how to work on the unit vectors I, J, and K. So this is work number 1. If vector A is equal to 2I minus 3J and vector B is equal to 4I minus 2j. So that is the first one. If A is 2I minus 3j and vector B is 4 vector I minus 2j, it's a unit vectors. And A is represented by vector A, and at the same time B is represented by vector B. Let me write this properly, vector A. Then find AB vector, find AB vector in terms of I, J, and K. So that is question 1. Question 2, add 5I. So add A is equal to 5I minus J minus 4K, and B is equal to, vector B is equal to minus 3J plus 2K. So add this so that what I'm expecting from you is to give me the value of vector A plus vector B. Otherwise, you can still go to KLB. Page 211 and try number 4 of exercise. Try number 4 of exercise 11.3. With that, I want us to look at what we plan to look at in the last part of today's lesson. That is what we are referring to as magnitude of a vector. Now, this is not something new. We've already looked at it when we were dealing with vector 1, magnitude of a vector. And I told you that the magnitude of a vector is normally what we are referring to as the length, and is also sometimes what we call as the modulus. So magnitude of a vector, length of a vector, and modulus of a vector is the same thing. Now, normally when, for example, we want you to get magnitude of vector OP, normally we will use this symbol OP like that, or sometimes simply say OP that way. So that is the magnitude of vector P. Now, when you have 3 points, say vector OP, if you can write it in column form as X, Y, Z, I'm giving you a general rule. So this is generally. If OP is that, then the magnitude of OP is normally given as the square root of X squared plus Y squared plus Z squared. I will give us an example so that it makes sense for us. Suppose you have, you have a vector, say vector AB, as 2, 3, 4. Then its magnitude AB, will be given by the square root of 2 squared plus 3 squared plus 4 squared. So in that instance, you will have 2 squared being 4, plus 3 squared being 9, plus 4 squared being 16. So this will give us the square root of 29. Now later you can use your calculators to get the value of root 29. Root 29. Sometimes we don't have such a straightforward question. You are told, for example, vector A, and you are told it is I minus 3k, like that. And you are asked to get the magnitude of this vector. Now, the most important thing, first of all, is to write this as a column vector, in which instance it will be vector A is equal to, now, you look at the coefficient of I. In this case, the coefficient of I is 1. That is why we still have it, so you write 1. Now, you realize that here we don't have j, meaning the value of j is 0. And then the coefficient of k here is minus 3, that way. So finally, to get now the length of A, or the magnitude of A, it will now be the square root of 1 squared plus 0 squared plus minus 3 squared, which will give us the square root of 1. Now 0 squared is 0, and minus 3 squared is actually 9. So this will finally give us the square root of 10, which we can use our calculators to find. So that brings us to the end of the subtopic magnitude of a vector. And what we can now do is that I can leave you with an assignment for further practice. So in our assignment, I want you to try, you'll go to KLB, exercise 11.4, and try number 1C. Try number 1C. For now, I want us to stop there, learners, until our next class. So I want you to remember that what we have learned today is the concept of unit vectors in a three-column dimension Cartesian, where we've looked at the unit vectors I, j, and k, and also we've looked at what we call the magnitude of a vector in a three-dimension Cartesian plane. Until next time, have a nice time.
CPE students can now access top-notch lecturers anytime from anywhere. Download CPE video lectures from www.manifestedpublishers.com.
Here's how to access the video lectures. 1. Sign up as a new customer at www.manifestedpublishers.com. Fill in the required credentials, full names, email, phone number, and password. Click on Sign Up. Enter the code received on your phone or email address for verification of your account. Proceed by clicking on Confirm button. Your account is ready for use, and you can watch some free sample videos before you purchase.
Disclose.
To get access to the complete videos, use the following steps to buy. 1. Click on View All Courses. Select the course you want to buy. Click on the subject you want. Click on Buy this subject. The selected subject will be added to cart. Place or hover the cursor on the cart or total amount and click on Check Out Now to proceed. Click on Lipa na M-Pesa and proceed to pay. Go to M-Pesa on your phone, select Lipa na M-Pesa, then the Pay Bill option. Enter business number 796533. Enter the account number provided. Enter the total amount, not less or more. Enter your M-Pesa PIN and send. You will receive a confirmation SMS from M-Pesa with a confirmation code. Thereafter, you will receive an email confirming receipt. To access your lessons, place your cursor on your name, then click on Subscriptions.
Learners, welcome to today's lesson. In our last lesson, we introduced the topic of transport in animals. And we say that animals require an elaborate transport system because they have a small surface area to volume ratio. So food materials and other substances must be transported within an elaborate system. And the system is a circulatory system. We looked at the various types of circulatory system or systems, that is an open circulatory system and a closed circulatory system. And what came out clearly is that for open circulatory system, blood is transported within the body cavity or the hemocoel. And while for the case of closed circulatory system, transport fluid is transported within special tubes called the vessels, and the transport fluid is the blood. We looked at the types of circulation, that is single circulation and double circulation. In single circulation, blood flows through the heart once in a complete circulation. For example, the case of the fish. While in double circulation, blood flows twice through the heart in a complete circulation. We also looked at how blood flows into the heart and out of the heart, and through that we have got what we call pulmonary circulation and systemic circulation. We looked at even the differences between the various types of circulation, and we concluded with some assignment. Today, and even before we look at today's work, we also saw circulation in examples of animals that have got closed circulation. For example, we looked at the insects, which have got open circulatory system. And we say that insects like cockroaches, they have a typical example of an open circulatory system where there's a tubular dorsal heart. We also looked at circulation in the fish, where blood flows from the body tissues and it enters the two-chambered heart, that is the atrium. Then it flows into the ventricle. Then it is pumped into the capillaries within the gills for them to acquire oxygen before they flow back, before it flows back into the body tissues where it is used. That is now oxygen. Then we also looked at examples of animals where double circulation takes place. That is the birds and the mammals. So for today's lesson, we want to look critically at circulation within the mammals. So we have the mammals having some circulatory system. So we have got a mammalian circulation system. So today we are looking at mammalian, that is the mammals, mammalian circulatory system. So under mammalian circulatory system, we are going to see how blood is transported within pumped from the heart. Remember, we say that there must be a mechanism for pumping blood, and because of that, the mammals have got a four-chambered heart. So mammals have got a four-chambered heart. So the heart is four-chambered. Four-chambered muscular heart. And the muscular heart has got two atria and two ventricles. two atria and two ventricles. So first of all, and these two atria and two ventricles, we have got the right atrium and the right ventricle. Those two deal with blood which is deoxygenated. So we have the right atria, and it is atrium now because it is one, and the left and the right ventricle. These ones, they deal with the deoxygenated blood. They deal with deoxygenated blood. That is blood that is coming from the rest of the body where all the oxygen has been utilized, so it must come back to the heart for oxygenation. And it enters the heart through the vena cava. The vena cava receives it, it enters the right atrium, then flows into the right ventricle before it is now pumped to go to the lungs via the pulmonary artery. Then the other two, that is the left atrium. We have the left atrium and the left ventricle. These ones, they deal with blood. They deal with blood which is oxygenated. So this blood which is oxygenated or is rich with oxygen, so we can maybe talk of it's rich with oxygen. The blood is rich with oxygen. So those two, they deal with that. And that blood that is rich with oxygen, that blood flows from the lungs and enters the left ventricle. And this left ventricle is the one that now eventually pumps the blood under high pressure to the rest of the body via the aorta. So those two, they deal with blood that is rich with oxygen. Then we have the blood that is deoxygenated has to go back to the lungs for oxygenation. So this is the introductory part of the mammals. Then we look at the external structure of the heart. External structure of the heart. Because before we look at how it functions, we must be able to know the structure for us to understand how it functions. Now, when the heart is seen from the external, it has got those four chambers. Of course, there are the four chambers that are responsible for dealing with oxygenated blood and deoxygenated blood. And the heart is covered by a membrane. This membrane is called the pericardium. So we have a membrane called the pericardium or the pericardial membrane. This pericardium is the one that encloses the heart, and the pericardium, one function is that it contains a layer of fat which cushions the heart against mechanical damage. So that is the pericardium. Then surrounding the chambers, we have, of course, the other vessels. That is the pulmonary artery. We have the pulmonary vein. We have the aorta, which bring in blood or takes out blood out of the heart. So that is the external part of the heart. So it has got we have got right ventricle. We have left ventricle. We have right atrium. Then we have left atrium. And the main vessels that supply this heart, we have the pulmonary artery. Pulmonary artery is the one that is responsible for conducting blood from the right ventricle to the lungs where it has to be oxygenated. Then we have another blood vessel, that is the pulmonary vein. The pulmonary vein is responsible for conducting blood from the lungs where it has been oxygenated back into the heart before it is pumped out. Then the other blood vessel is the aorta. The aorta is the one that pumps oxygenated blood to the rest of the body. We have the aorta. Then finally we have the major vessel that brings in blood to the heart, and that is the vena cava. The vena cava. So the vena cava brings in blood that is deoxygenated into the lungs. So those are the major parts. Then, of course, we have other structures that we are going to look at when we are going to look at the internal structure of the heart. So we want to see how the heart functions, and before we also look at how it functions, we must look at the internal structure of the heart. The heart, first of all, we have noted it is muscular, and just to add on the external part of the heart has the responsibility of pumping blood that is oxygenated to the rest of the body with the nutrients. But the heart itself also has got special muscles. That's why you are saying it is muscular. So besides these other parts, the heart has got what we call the special muscles known as the cardiac muscles. So it has got the cardiac muscles that pumps blood into the heart. And these cardiac muscles, they serve the heart, and the heart also has got an artery which serves it. The artery that serves the heart is known as the coronary artery. So we have the coronary artery that serves the heart. We have the coronary artery. So besides here, we have got coronary artery, which is found on the surface of the heart. So we have coronary artery. It is found on the surface of the heart. So these structures are ones that they can be observed externally. And for internal structures, they are the ones which will be observed if the heart maybe is cut through a certain section, like for example, we have a transverse section. So these are the external structures. So the heart itself also is served with blood that is rich with oxygen. And once we have the coronary artery, then we shall also have what we call coronary vein. So we have a coronary vein. Coronary vein. So the arteries supply oxygenated blood to organs and tissues, while the veins, they carry away the oxygenated blood from the tissues and organs back to the heart where it is oxygenated. So the coronary artery does that supply of the nutrients, while the coronary vein will carry away the blood that is deoxygenated from the heart to the lungs. It is only the lungs which do not have veins and artery that supply them, because already the lungs have enough oxygen with it. The oxygen is never exhausted. So looking at the external structure of the heart, we have, first of all, we have the right atrium. So the right atrium will come there. This is just a sketch. The right atrium. The right atrium, blood comes in from the rest of the body. So this is the vena cava. That is the vena cava. So the vena cava brings in blood. So blood comes in and flows into that. Then, of course, we have here now the blood that will now be going to the lungs. So blood going to the lungs. So we have that kind of a structure. So there's a kind of a connection. So that's the atrium. Then below it we have the ventricle. And this is the right atrium, because there are two. Then here we have the right ventricle. So the right ventricle, blood now is flowing in. So blood will come here, and we have got vessels. We have vessels here, and this vessel here, not vessel, the valve is called tricuspid valve. So here it is tricuspid because thrice it is three. So there are three valves that meet here. So this one, they form what we call tricuspid valves. Tricuspid valves. So then we have here something like a demarcation, something that is separating the chambers so that blood does not mix. So we have something that separates, and that chamber we are going to give it the name. So blood coming in is deoxygenated, so it flows into the ventricle. And once it flows into the ventricle, it has to go to the lungs. So that blood will come out through there, and here there's a valve. The purpose of valves is to prevent blood from flowing backwards. So because it has to go and does not need to flow backwards because it will mix. So here we have another valve here. This valve here is known as the semilunar valve. So this is the semilunar valve. Or valves are found there. There are two of them. Then so blood is flowing now. Deoxygenated. This is deoxygenated blood. It is now going to. It's now going to the lungs. So it will be pumped by the right ventricle. It's going to the lungs to be oxygenated, and for it to reach there, there is an artery. So, and it's the only artery that carries the oxygenated blood. That is the pulmonary artery. That is the pulmonary artery, which carries blood to the lungs. So the blood goes now to the lungs. That blood, as it goes to the lungs, it has to come back from the lungs. So, and here we have, now we shall have another valve there, another vessel. So here we have that. So here we have the other two chambers. So the other two chambers we have here, this is the left ventricle. So the left ventricle is just adjacent to the right ventricle. Then here we have now, this is the right ventricle, so this will be our left atrium, sorry, that is the left atrium. Then we have this valve here that prevents the flow of blood backwards. So that valve is known as the bicuspid valve. So this is the bicuspid valve. And then, of course, blood will come into this ventricle, left ventricle, and that blood comes in from the other side. So here we shall have blood coming in. It has to come in. That is, it comes in there. So blood will come in. Through there, and it comes in through here. So blood will come in through that vessel. So it comes in, but it has to come into the left ventricle before now it is pumped out. Before it is pumped out. So it will be pumped out, and it is pumped out through the aorta, while this one brings in blood. So blood will be flowing in. So it flows in like that, and it flows in here, then flows out, through the aorta to the rest of the body. Then here we have this is the pulmonary vein. Pulmonary vein, this one. So this is a sketch of the heart. So, and in this sketch, we have got another structure that is very important. This muscular structure here, this one that is dividing the two chambers. So this is called the septum. That is called the septum. So the septum divides the right atrium and the right ventricle from the left ventricle and the left atrium. Because this side here, as you are seeing, the oxygenated blood is coming in. So it's not supposed to mix. It is supposed to go to the heart, to the lungs straight for oxygenation. Then blood also coming from the lungs is now oxygenated. It must come straight into the ventricle and without mixing, and that function of them not mixing is achieved by the presence of the septum. Then blood will now be pumped out and it goes out through the aorta. So this is the structure of the heart. Now, we want to see how now blood, how it connects. Once it has flown out from the aorta, now it is going to go to the tissues. So the aorta is a very important artery. This aorta here is very important because it is the one that is now pumping blood under high pressure. And it must be noted that the left ventricle is more muscular than the right ventricle because it requires muscles that will provide energy that will pump blood under high pressure until this blood reaches all the tissues, because it's the final phase of pumping blood out of the lungs. Now, from the aorta, blood now goes to various arteries. So blood from the aorta. So now here we have got flow of blood. So blood now flows from the aorta. So we have the aorta, which has oxygenated blood. So blood will flow from the aorta. Now it goes into the arteries. So blood goes into the arteries, various arteries, and these arteries, most of them are found within the various organs. We shall name a few of the major arteries that we find within the body in a short while. Then we have from the arteries are bigger. So now they divide into smaller vessels known as arterioles. So it now flows into the arterioles. And these arterioles will now subdivide even further to even much smaller vessels known as the capillaries. So from the arterioles, we have the capillaries. Now, the capillaries are found within the various tissues where now the blood is required. That is now blood rich in oxygen. And the reason why it goes into the tissues is because oxygen is required for the process of respiration, which will bring about energy production. And the energy production is very important to the body cells. So now from the capillaries, blood will be in the tissues, oxygen will be used up. This blood is supposed to go back to the heart now again, before it goes to the lungs for oxygenation. Now, how does it go to the heart? It goes to the heart again by these capillaries reuniting to form smaller vessels referred to as the venules. So we have the venules that now is now going to carry the oxygenated blood. So this blood is not supposed to mix, so they take different routes. Blood coming in that is deoxygenated will take a different route from blood that is leaving and going to the heart. So from the venules, the blood vessels divide into even bigger vessels known as the veins. So the veins will carry that blood. And then these veins, if you look at the structure of the heart, those veins are connected to the vena cava. So various veins will be connected to the vena cava. So blood will now enter the heart via the vena cava. So here now we shall have the vena cava. So you can see now blood is now back, but now deoxygenated. So it comes back and the circulation continues. So, and the heart will continue pumping throughout. So that's how blood flows from the heart. Then we have got, what we are saying that we have got examples of these, examples of arteries and veins. Arteries and veins. So we have some examples. Maybe you can have a table showing examples of arteries and veins. Now, we can just pick examples that we even already have, for example, and maybe you can write here which organ they supply. So we have here organ. So for example, we have the heart. We are saying that the heart has got a coronary artery. The heart has got a coronary vein. So here we have an example like coronary artery. Then we have coronary vein. So here we are saying it is, these ones they supply the heart. They supply the heart with the same. Then we are also seeing that we have got, for example, we have the liver. It's a very important organ because liver has got very many functions. So liver is one organ that requires a lot of oxygen. So we have got what we call hepatic artery. Hepatic artery. And once we have hepatic artery, then we shall have hepatic vein. Then this one we are saying it supplies the liver. Then we have the kidney, a very important organ that takes part in excretion. The kidney has got what we call the renal artery. So we have the renal artery. Then we have the renal vein. That is the kidney. So that one supplies the kidney. Then we have the eye. A very good simple example of the eye. We have the eye is an example, but we could look at maybe another example that we have. For example, we have coronary. Once we have the artery, we have the vein. But I wanted to not the eye, but the lungs. The lungs are a bit unique because you see the lungs, the pulmonary artery is the only artery that carries the oxygenated blood, while the pulmonary vein is the only vein that carries oxygenated blood, because you know that arteries carry oxygenated blood while veins carry deoxygenated blood. So that is a bit unique. That is about the heart. So these are examples that we have. And with that, we have come to the end of this. But what we are noting is that the mammalian circulatory system is one of the most elaborate systems, because we can see that the mammals have got a 4-chambered heart, a very big chamber, and it is divided into clear-cut chambers that ensure that deoxygenated blood and oxygenated blood do not mix. Then secondly, we have also noted that we have got a septum that divides the right ventricle and right atrium from the left atrium and the left ventricle. Then we should also note that the left ventricle is more muscular than the right ventricle, because the left ventricle requires a muscular ventricle in order to pump blood to the rest of the body under high pressure. That's why it must be muscular, to provide that energy like that. It has also been noted that the heart is also supplied by vessels. That is the coronary artery and the coronary vein. Very, very important. Then we've looked at how blood flows, the flow of blood, and it flows in a circular manner to ensure that the blood does not mix. That is flowing right from the aorta to the arteries, flows right from the aorta to the arteries, and it flows through the arteries to much smaller vessels known as the arterioles, and the arterioles further divide into even much smaller vessels known as the capillaries, which are found within the tissues. So once the blood is in the tissues, oxygen is utilized in the process of respiration, and of course carbon dioxide is produced, and carbon dioxide is toxic. It has to be eliminated from the body before it accumulates to levels that are harmful to the body. So the route that carbon dioxide takes is by flowing through vessels known as the venules, and these venules now reunite. They are now reuniting to form bigger vessels known as the veins, which are now connected to the vena cava. And once they reach the vena cava, blood now enters the heart, into the atrium, into the right ventricle, then it is pumped out to go to the pulmonary artery, into the lungs for oxygenation. And then once it's oxygenated there, it comes back to the heart and is pumped out. So that's the circular manner in which blood flows. That has to be noted very clearly. Now, for purposes of preparing for the next lesson, we are going to look at how the heart functions and the mechanism of pumping of blood within the body. And the following can be looked at in terms of revision, and it's very, very important. One, state two advantages of a double circulation. Two, define the term pericardium. Three, state two significance of pericardium. Then lastly, name special muscles found within the heart. So those ones can be looked at in terms of revision. I wish you well as we continue pursuing this series of biology. Thank you.
Welcome to Manifested Publishers.
Hi, my lovely learners. I am so excited to have you again on this platform. Remember, this is Manifested e-learning platform, and I am Teacher Purity. So we are going to learn hygiene and nutrition activities for grade 3, and we are starting on a new topic about the use of improvised materials for cleaning utensils. Under the use of improvised materials for cleaning utensils, we shall start by learning the types of dirt that are found on utensils. So, welcome to the lesson and hope that you are going to enjoy. Now, types of dirt that are found on utensils. Utensils are the things we use at home to serve and cook food. So remember, when you cook from a sufuria and also serve your food from a plate, they get dirty. So we want to see the types of dirt that are found on utensils. Now, we clean utensils at home to keep away germs. Germs can cause diseases and can make us to fall sick. So we clean utensils at home. So we clean utensils at home to keep away germs. Remember, germs are not good for our health. When you serve your food from a dirty plate, you can become sick. We also wash utensils or clean utensils at home to keep away pests such as cockroaches. We clean utensils to keep away cockroaches. We clean utensils to keep away cockroaches. dirty utensils attract cockroaches. No, so now that is the reason why we clean utensils at home. First, to keep away germs, and second, to keep away pests like cockroaches. So what are some of the types of dirt that are found on utensils? So types of dirt. The first type of dirt that found on utensils, we can have milk dirt. Milk dirt is the first one. Now milk dirt includes the dirt, maybe that a cup that you've used to drink your tea or even yogurt. So milk dirt is a type of dirt found on utensils. Then we have another one, we call it grease dirt. Now grease dirt includes that has come from oily foods like meat or fish or eggs. So grease dirt looks oily. Then we have the last one, we call it starch dirt. Starch dirt. Starch dirt is the remains of food that remain on a plate. We call them starch dirt. So these are the main types of dirt that are found on utensils. The first one is a milk dirt. Now this is an example of milk dirt. This cup was used to drink tea and therefore there are remains of the tea. So this one is milk dirt. Then we have grease dirt. Grease dirt is the dirt that remains on plates or utensils that you've used either to serve meat or fish or eggs. Then we have lastly starch dirt. So starch dirt is the remains of food that remain on a plate after you've eaten. So this is an example of starch dirt. Can see there are remains of food on the plate. We call them starch dirt. So these are the main three types of dirt that are found on utensils. The first one, we have milk dirt. Then we have grease dirt, and lastly, starch dirt. Milk dirt is when you have used a utensil to serve milky foods. Then grease dirt is the remains of oily foods like the fish, fried eggs, or meat. And lastly, we have starch dirt. These are the main types of utensils that are found, of dirt that are found on utensils at home. And we are supposed to clean our utensils every day. Remember to keep away germs and also to keep away pests like cockroaches. So back at home, I want you to visit your kitchen. Check where the dirty utensils have been placed and try to identify the three types of dirt: the milk dirt, grease dirt, and the starch dirt. Meanwhile, I'll give you some work for you to copy. Get ready with your exercise book, pencil, and rubber. The question, write down three types of dirt found on utensils. You will write the three types of dirt found on utensils. Fill your answers in blank space number 1, 2, and 3. Then make sure that you are going through your work after you have completed it. So hope to see you in the next lesson, and thank you for attending the lesson.
Welcome to Manifested Publishers.
Hello learners, welcome to today's biology lesson, Form 3. My name is Stephen Kariungi, and we continue with our topic of discussion, which is sexual reproduction in plants. So today we are going to discuss pollination. So the first thing that we ask ourselves is, what is the meaning of the term pollination. The term pollination comes from the word pollen. So that means that it involves pollen. So we can say that pollination is the transfer of pollen grains from the anther to the stigma. Pollen grains are produced in the anther, and they need to be transferred to the stigma during pollination. So we can say that this is the transfer of pollen grains from the anther to the stigma. Now, we have two types of pollination. Types of pollination. The first type of pollination, we refer to it as self-pollination. And self-pollination is whereby the transfer of pollen grains is from the anther to the stigma of the same flower or of another flower within the same plant. So basically in self-pollination, we don't move outside one plant. So it's either from one flower to another flower within the same plant or from the anther to the stigma of the same flower. So we can say that this is the transfer of pollen grains from anther to the stigma of the same flower or another flower within the same plant. So we are saying that self-pollination is the transfer of pollen grains from the anther to the stigma of the same flower or another flower within the same plant. So basically, we don't move outside that particular plant. The other type of pollination is what we call cross-pollination. And this is the transfer of pollen grains from the anther. It has to be always from the anther to the stigma. Of another flower in another plant. So this one has to be in another plant, but of the same species. So basically, cross-pollination, there is the transfer of pollen grains from the anther to the stigma of another flower in another plant, but that plant must be of the same species. So it has to be from this plant to another plant of the same species. So that is what we call cross-pollination. Now, in cross-pollination, we can say that there is mixing of genes because one plant is not completely identical to the other. So in this case, there are some small variations that exist in terms of their genetic makeup. So in this case, we can say that cross-pollination leads to exchange of genetic material which leads to variation. So this is one of the sources of variation, or this is one of the causes of variation. When there is mixing of genetic material between different plants of the same species, then that brings about what we call variation. Now, the other things I want us to discuss are the agents of pollination. Note the difference between the types of pollination and agents of pollination. The agents of pollination are the ones that aid the movement of pollen grains from the anther to the stigma. These agents can either be animals, for instance, insects. Insects are the main animal agents of pollination. Or another agent of pollination can also be wind. So mainly there are those two. So two main agents of pollination are insects and wind. So we are going to look at what are the adaptations of insect pollinated flowers. What are some of the features that they have so that the insects become the agents of pollination, to attract these insects so that they can come and help in the transfer of pollen grains. So we look at the adaptations of insect pollinated flowers. And those insect pollinated flowers, we also refer to them as entomophilous. Entomophilous flowers. We know that entomology is the study of insects. So for those flowers that are pollinated by insects, we refer to them as being entomophilous. Now, one of the features that you'll observe in these insect pollinated flowers is that they usually have very large petals, very conspicuous. You can see them from a distance. And they are usually brightly colored. So you can say that one of the adaptations is that the petals are large, conspicuous, and brightly colored. To attract insects, which are the agents of pollination. So when they are large and conspicuous, the insects can easily see them from a distance. When they are brightly colored, the insects can also be able to see them from a distance. Number two is that they are usually scented. That is, have scent that attracts insects to them. So the insects are attracted also by the scent that is produced by these flowers. The other thing about the insect pollinated flowers is that they have small anthers that are located within the flower. They have small anthers that are located within the flower and produce a relatively lower number of pollen grains. So the number of pollen grains that are produced here, they are not so many because there is minimal wastage. There is minimal wastage. Also, we are saying that the anthers are small and located within the flower. So chances of these anthers losing the pollen grains are minimal. As for the pollen grains themselves, the pollen grains are large. They are relatively large and sticky. They are large and sticky to attach or to allow them attach on the insect's body. On the insect's body. So they are sticky so that they can attach onto the insect's legs. They can attach onto the insect's wings as they are being transferred from one point to the other. These insect-pollinated flowers also have nectaries that produce nectar. And this nectar is the one that attracts insects. The nectar attracts insects to feed on them. Feed on them. So the nectaries produce nectar that attracts the insects. Number 3, these flowers are usually funnel-shaped. They are funnel-shaped, forming a landing platform. So that the insects can be able to land on them, forming a landing platform for the insects. So basically, those are some of the adaptations of the insect-pollinated flowers, such as hibiscus and most of the commonly seen brightly colored flowers. So you've seen that the petals are large, conspicuous, and brightly colored to attract the insects. They are usually scented, or they have scent that also attracts the insects to them. They have small anthers located within the flower and produce a relatively lower number of pollen grains because there is minimal wastage. The pollen grains are large and sticky so that they can be able to attach on the insect's body when they are being transported. They have nectaries that produce nectar, and that nectar attracts the insects to feed on them. And finally, we've seen that their shape is funnel-shaped, that is wider at the top and smaller at the base, and that is to form a landing platform for the insects during pollination. So we'll stop there for now, and then we look at an assignment on the same. So the first question, what is pollination? Second question, name the 2 types of pollination. And number 3, state and explain 5 adaptations of insect pollinated flowers. So we are going to stop there for today. Goodbye.
Welcome to Manifested Publishers.
Hello learners, welcome to today's biology lesson. My name is Stephen Kariungi. Today, we'll continue with our discussion on Introduction to Biology, a topic in Form 1. And today we are going to look at collection of specimens. What are specimens? Specimens are materials obtained from living organisms that are used for the study of biology. We can get specimens from plants, from animals, and from other living organisms so that they can enable us to understand biology better by using those specimens. So basically we can say that specimens are materials obtained from plants and animals to aid in the study of biology. Now, these specimens sometimes may be live specimens, whereby we may be required to collect specimens that are alive. For example, insects are live specimens for the study. Other times, we can collect specimens that are not alive. Maybe specimens such as leaves, such as roots, and so on and so forth. Now, when collecting specimens, especially the live specimens, there are some precautions that one needs to take. Some of the specimens can cause injuries. Things like the insects, some can sting, others can bite, others are poisonous, and therefore it is important to take precautions. So it is necessary to understand what are the precautions that are required during collection of live specimens. So the precautions required during collection of specimens, 1, we are supposed to collect only the specimens that we need in our study to avoid wastage and destruction. So we should not go collecting specimens that we do not need. So we are supposed to collect only the required number of specimens. So to avoid wastage, we need to collect only the number that we require. Number two, during the specimen collection, we should not destroy the habitats or the homes of those specimens. So care should be taken that we should not destroy the habitats. We should not destroy the habitats of specimens being collected. We will need those habitats in future. Now, when collecting live specimens, care should be taken about those specimens that can cause injuries. They should be handled with care, and they should be handled with the right equipment. For example, if an insect can sting, it's advisable to use the forceps to hold that particular insect or to collect that particular insect. So when collecting injurious specimens, care should be taken by use of appropriate equipment or apparatus. Now, after collecting the specimens and after carrying out the study, live specimens should be returned back to their habitats unharmed, without being harmed at all. So after study, or after the study, the live specimens should be taken back to their habitats unharmed. So we should make sure that those specimens are not harmed at all. Now, we also have some specimens that are highly mobile, that move very fast, like the centipedes. So for those highly mobile specimens, they should be immobilized. They should be slowed down using particular agents so that they can be caught easily. So highly mobile live specimens should be immobilized. Should be immobilized using suitable reagents before collection. So basically, those are the precautions that one requires during the collection of specimens. Now, it is also important to understand which are some of the apparatus used for specimen collection. apparatus or equipment used We'll name a few. For example, we have the sweep net. This one is for catching flying insects, things like the wasps and so on and so forth. We have the fish net. This one is for catching fish and other animals in water. We have the bait trap. This one is for attracts and traps small mammals, e.g. rodents, such as the rats and the mice. We use the bait trap, whereby the bait attracts them and then they are caught by the trap. We have a putter that is used to suck small crawling animals from rocks or barks of trees, things like the aphids that can easily be sucked. They are sucked using a putter. We have the pitfall trap, and this one is for catching crawling animals which fall into a pit. We have specimen bottles, and these ones are for storage of specimen during collection. So the list is long. There are many apparatus, many equipment that we use during specimen collection, as we have seen. So basically today we have learnt about the precautions that we need to take during specimen collection, that we should not injure the specimen, we should not destroy their habitats, we should only collect the number that we need to avoid wastage. For those specimens that are highly mobile, they should be immobilized by use of suitable reagents before collection. And then finally, after we have completed the study, the live specimens should be taken back to their habitats to avoid, of course, destruction of the ecosystem. Now, also, we have learnt about the apparatus or equipment that we use for specimen collection. There is a sweep net for catching flying insects, the fish net for catching fish and other animals in water, bait trap, this one attracts and traps So this one, attracting and trapping. Small mammals, e.g. rodents, such as rats and mice. We have a putter for sucking small animals from rocks or barks of trees. We have the pitfall, whereby we catch crawling animals by making them fall into a pit. And then finally, the specimen bottles that are for storage of specimen. So all those are part of the apparatus that we use for specimen collection. So we are going to have an assignment on that. So the first question in the assignment, state and explain 5 precautions that a student should take during specimen collection. Number 2, draw the following apparatus and state their functions. A, putter, B, forceps, and C, a bait trap. So we are going to stop there. See you next time.
Enroll your child for the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Hello students, welcome to Manifested e-learning platform. My name is Wilson Andove. I'm your literature teacher. In the previous lesson, we began talking about aspects of poetry, and the dominant one was rhyme. And we said that rhyme is the matching of sounds at the end of lines. So before we go into today's lesson, I want us to have a brief recap of what we talked about rhyme. We said that rhyme is the matching. This is the matching of sounds at the end of words in a line in a poem. That is rhyme. And I want to give just an example of what I gave you in the previous lesson. There's this short poem. Now, to demonstrate rhyme, I want us to recap this poem that we had looked at in the previous lesson. We said we are looking at the end of lines. We are looking at the last word at the end of the line, in a line. So the word that we are looking at is reeds. It runs through the reeds, and away it proceeds through meadows and glade, in sun and in shade. So in rhyme, we look at these words. So the word read and proceeds, they have the same sound. So these are rhyming words. Reads and proceeds are rhyming words. So are glade and shade. So we call this end rhyme. End rhyme, because it's coming at the end of a line. You can see reads and proceeds. These words are rhyming, but they're coming at the end of lines. Glade and shade are also rhyming words, but they're coming at the end of the line. So we call this end rhyme, meaning rhyming words come at the end of a line. Okay? Now, in today's lesson, I want us to look at another form of rhyme that we call internal rhyme. Internal rhyme. Now, just like end rhyme, where sounds match, in internal rhyme, we'll find that a word that is in the middle of a line will match with a word, will match with a sound that is at the end of the line. So in internal rhyme, we find that sounds match. Sounds which are in the middle of a line will match with the sounds at the end of a line. So we say the matching of sounds that are in the middle of a line with those at the end of a line. So that is internal rhyme. The sounds at the middle of a line and at the end of the same line are matching. We call that internal rhyme. And I want us to look at an example of internal rhyme. And here is a poem. Here is a poem entitled The Raven by Edgar Poe. I said in the previous lesson that the writer of a poem is called a poet. So in this case, Edgar Poe is the poet, the writer of this poem, The Raven. So the poem says, the ship was cheered, the harbor cleared, and every day for food or play, in mist or cloud, or mast or shroud, while all the night through the smoke white, the fair breeze blew, the white foam flew. Now I want us to look at this poem while we are matching sounds. In this case, we're going to look at the sounds, we're going to look at the words at the end of lines. So we're going to look at these words which are coming at the end of lines and the sounds at somewhere in the middle of the line. So I'll go through the poem again slowly. The ship was cheered, the harbor cleared. Now in the first line, you can get the fact that the word cheered and cleared have the same sound. So cheered and cleared are rhyming words. It's only that cheered is coming somewhere in the middle of the line. It's not coming at the end. So the ship was cheered, the harbor cleared. So cheered and cleared are rhyming words. But this word comes somewhere in the middle of the line. So we call this internal rhyme. Look at the second line. And every day for food or play. And every day for food or play. So the word day and the word play are rhyming. Get the sound A and A. Day and play. They're rhyming words. In mist or cloud, on mast or shroud. Cloud and shroud. So you also get this sound out. Cloud, shroud. So these two words, cloud and shroud, are rhyming words. While all the night through the smoke white. So night and white. You hear the sound night, it, white, it. So the word night and white are rhyming words. The fair breeze blew while the white foam flew. So again, blew and flew. These two words have the same sound. So students, if you look at this poem, you can see words which are rhyming. The only difference is some words are somewhere in the middle of the line. So the word day and play are rhyme. Only that day is somewhere in the middle of of the line, and play comes at the end of the line. So we call this internal rhyme. So we shall say internal rhyming words, and they are cheered and cleared. We have day and play. We have cloud and shroud. Then you have night and white, and lastly blue and blue. I hope that concept is understood. I'll just re-emphasize that internal rhyme, just like end rhyme, you'll find that a word that is used somewhere within a sentence, in most cases at the middle of the sentence, rhymes with a word that is coming at the end of that particular sentence, as we have seen these examples given here. So these are rhyming words, but we call these internal rhyming words. Unlike the end rhyme, whereby we only find rhyming words at the end of the lines. So I hope that is very clear. Now, students, I want to look at some other aspects of poetry, and we want to look at something called alliteration. Alliteration, and this is the repetition of consonant sounds at the beginning of words in the same line in a poem. The repetition of consonant sounds at the beginning of words in the same line in a poem. Now, students, I want to give an example of a tongue twister. Look at this tongue twister. If can tie a tie. Now, this is what we are talking about. We are talking about we are repeating consonant sounds. In this line, we have the following consonant sounds. We have ka, ta, and ta. Remember, students, we are talking about consonant sounds, not spelling. So, for example, can tie, this ka and the word can, both of them have the ka sound. The ka sound. So we say the word can tie and can are alliterating. I repeat, the word can tie and can are alliterating because both of them have sound ka, and I said it's about the sound, not the spelling. Please, students, be very careful, because some of us look at the spelling and we are saying it's about the sound, not the spelling. If can tie a tie. So we call this alliteration. Another example. Peter bought a pack. A pack of, let us have another one. Bitter butter. Peter bought bitter butter. Now, if you look at this sentence or this statement, you can see we have pa, sound pa, as in the word Peter. We have ba, as in the word bought. We have ba in bitter and then butter. So, in this line, we have this sound ba, ba, ba. These sounds have been repeated. Boat, bitter, butter, ba, 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 ba sound. So we call this alliteration. We are repeating the sound ba, and we say it at the beginning of words in the same line. So we call that alliteration, okay? Now, another example, another style we call assonance. Now, unlike alliteration, where we're repeating consonant sounds, in assonance we are repeating vowel sounds. So this is the repetition of vowel sounds in words in a poem. We are repeating vowel sounds in words in a poem. For example, kill and bill, kill and bill, will and bill, for example. If you look at these words, kill and bill, we have E, will and bill. So when you are repeating vowel sounds, A, E, this sound E, kill and bill, will and bill. So when you repeat such sounds, we call this assonance. Now please note, in assonance we are repeating vowel sounds in the same line in a poem. For example, kill and bill, will and bill, we are repeating the sound E. So we call this assonance. You need to underline it. Now we look at other styles which are common in poetry, other terms, sorry. The other term that is used in poetry is dialogue. Now, a dialogue is a conversation. This is a conversation between two or more characters in a poem. So in a poem, if you find two or more characters speaking, we call that dialogue. As long as you have two or more characters speaking, converse, we call that dialogue. Another feature that you need to know is called setting. The word setting means the place and time. The place and time when the actions in a poem take place. So it means the place and time when the action in a poem takes place. So if you are asked, what the setting of this poem? It means where. A poem can be set maybe in a classroom, can be set in a forest, can be set near a river, can be set in a church or a place of worship. So it means the place, and also time. Can be in the morning, late at night, or even a season. So we call that setting. Another common style is called simile. Simile. I'm sure while you were in primary school, you had similes like, you are told as fast as a cheetah. You have heard of such statements. As slow as a chameleon. As brave as a lion. So those are similes. So a simile, this is a statement that compares two things or people using the words like or as. For example, you say Jane, example, Jane is as fast as a cheetah. So we are comparing Jane with a cheetah. Jane is as fast as a cheetah. So we are comparing Jane. The speed of Jane is like that of a cheetah. So we call this a simile. He is as brave as a lion. Again, you can see we are comparing this person. He's brave like a lion. So we're comparing those two aspects. So we call this a simile. And you can have many more. I wanted to give other similes that you may know of. Related to the simile, students, it's another term that you call a metaphor. So you have a metaphor. Now, a metaphor is just like a simile, only that does not use the word as or like. So it compares a statement that compares two people or things without using the word like or as. Like or as. For example, if we say Jane is a cheetah. Jane is a cheetah. What does it mean? Does it mean that Jane is an animal? No, it doesn't. It means that Jane runs as fast as a cheetah. So this is a metaphor. James is a lion. Does it mean that James is an animal? No, it means that James is a brave man, just like a lion. So, words which compares two things directly, such statements without using the word as, they are called metaphors, and they are very common in poetry. So you should be able to get more examples. You can say, she is a bee. What does it mean? It means that she is a busy person. She's not an animal. So you should be able to identify use of similes and metaphors in poetry. Then, so students, before we finish, I want us to have a brief recap of what you have learned today. Today we have talked majorly about poetry and some other styles, but we said when you're dealing with rhyme, we have two types of rhyme. We have end rhyme and internal rhyme. End rhyme comes at the end of words, whereby you find that some words are matching. We call that end rhyme. But internal rhyme is whereby we find sounds which are somewhere in the middle of a sentence and that at the end of the sentence are matching. These are very good example: cleared and cheered and cleared, day and play. So we call that internal rhyme. We have gone ahead and talked about some other styles used in poetry, like dialogue, and we said these are conversations between two people. We have talked about setting, which means the place and time when an action in a poem takes place. We have also talked about similes and metaphors. Up to that, student, that will mark the end of today's lesson. Until next time.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take shit. I got no love
for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Everything I do so instinctive and so passionate. Every word I move so descriptive like an adjective. I got a vendetta against people who patented being negative when you should be getting after it. I got facts over tracks, this and that. Spitting slow, spitting fast. I could roast, I could gas. Think I'm okay at last, but I don't know if that can erase all the past. And the pettiness, a reflection of the emptiness. Hilarious, you think you're worth my time, you're delirious. Mysterious, because you hide behind a fake exterior. Inferior, you know I'll always be a bit superior. Get off of me, this ain't no humble brag. I want you to hear words, you can say them back. I want you to feel free from the chains at last, and to believe in what you got, it was built to last, yeah.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
Gonna learn the consequence of being incompetent. Mental health is confidence, dreams and some modestness. I'm not here to save the day, that's for you to take away. I could play a million mind games, but instead I say something not illogical, something that is topical. Rub it on and watch it go, make yourself unstoppable. Dreams are irresponsible, but they're always possible. If you just believe, you could be so remarkable.
Thoughts in my head, a collage and they spread. I'll be great one day, going off of my meds. No, I'm not giving up, no, I'm not giving in. I will make it to the top, taking off in the wind. I gotta make it, I'm saving every day to taste it. I'm patient, but my mind, it can hardly take it. I'm chasing a dream that I've had for several ages. A vacant, modern kingdom for the taking.
Now that I've been put through hell, I never got anyone's help. I had to do it all myself.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement. I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up and make a statement.
I don't ever slow up, no I don't take shit. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up.
Amelenga sehemu tofauti tofauti kulingana na maudhui. Na pale tumeona maudhui ya ufisadi, na katika maudhui ya ufisadi tumeweza kuona ufisadi wa unyakuzi wa ardhi, ufisadi wa utoaji wa hongo, tukaona pia vile vile maudhui ya umaskini, na pia vile vile tumeangazia maudhui ya ulafi. Hivi sasa wacha tuangalie maudhui ya umoja wa wananchi wa Madongo Poromoka. Lakini kama ilivyo ada na desturi, wacha nifanye nini? Wacha nidokeze ile somo ambalo tunalizungumzia kwayo leo. Ni Kiswahili. Alafu fasihi andishi. Alafu katika fasihi andishi yetu nazungumzia kitabu kiteule. Alafu tumbo lisiloshiba. Alafu bado tuko katika maudhui. Na leo tutazungumzia maudhui nambari 4 ambayo ni umoja wa umma. Naweza tukasema hivyo, ama wananchi. Umoja ni nini? Umoja ni mshikamano, maelewano, kufanya jambo fulani kwa dhamira moja. Huo ndio tunaweza kusema ni umoja. Pia vile vile tunaweza tukatumia kisawe chake kuonyesha umoja wa umma ama wa wananchi. Wananchi wanapokuwa na umoja katika sehemu yoyote ile, wanapolenga jambo fulani, basi huwa jambo lile ambalo wamelikusudia bila shaka litaweza kufanikiwa. Wacha tuangalie umoja wa wananchi wa Madongo Poromoka kulingana na mwandishi huyu wa hadithi fupi ya Tumbo Lisiloshiba. Kwa hivyo tutazama moja kwa moja, na kama nilivyotangulia kusema pale awali katika uchambuzi wangu, ni kwamba unapotoa maudhui yako, wewe uelekezwe na ile hadithi ambayo unaizungumzia, wala usiende nje ya hadithi yenyewe. Kwa hivyo wacha nizame katika hii hadithi fupi ya Tumbo Lisiloshiba, nikijadili maudhui ya umoja wa umma ama umoja wa wananchi ambao wako katika eneo la Madongo Poromoka. Ukumbuke kwamba kulikuwako kuna njama nyingi sana za matajiri waliokuwa wanataka kuwafanyia hujuma, kuwafanyia hila, kuwanyang'anya wana Madongo Poromoka eneo lao. Wacha tuangalie, je, umoja wao wa kutetea Madongo Poromoka uliweza kuleta ufanisi? Wacha nitaangalia ukurasa wa 5 katika hicho kitabu chetu cha Tumbo Lisiloshiba. Nitaanzia kusoma pale chini baada ya vile vinyota vitatu. Pale panapo mkahawa Mshenzi, tunamkuta mzee Mago kaketi na wana Madongo Poromoka wenzake. Kwa hivyo hapa yuko na wenzake. Mzee Mago yuko mkahawani na wenzake. Hii ndio asili ya umoja. Wanafanya nini pale kwenye mkahawa na wale wenzake? Anasema hivi, wana Madongo Poromoka wenzake wanakunywa chai na kuzungumza. Kuwe na mazungumzo gani hasa yatakayomchangamsha kila mtu wakati huu kuliko uvumi ulioanza tena kuvuma? Tena kuvuma kwenyewe kwa nguvu zaidi nchi nzima. Kulienea uvumi kwamba eneo zima la Madongo Poromoka karibu litabwagwa chini na kuchukuliwa na vizito wenye fedha zao. Kwa hivyo hapa mzee Mago na wenzake, ambao nitakutajia majina jinsi tunavyoendelea kusoma hiki kitabu chetu, wanazungumzia kuhusu swala moja tu, namna umoja wao utakavyoweza kufanya nini? Kutetea ile ardhi yao ya Madongo Poromoka ambayo imepangiwa kufanya nini? Kubwabwa chini na wenye vyao vizito, matajiri na kadhalika. Wacha tuendelee. Hawawezi, alitamka Kabwe. Hawawezi kabisa, hawawezi, alisisitiza. Jambo gani litakalowafanya wasiweze? Aliuliza Mago bila ya kufikiria. Kwa hivyo mhusika wa kwanza, mhusika pale mkahawani, ama wacha nitumie neno wahusika pale mkahawani. Wahusika pale mkahawani, wa kwanza ni mzee Mago, wa pili Kabwe. Wacha tutaona mhusika wa tatu. Wamechelea umma wa madongo poromoka. Hapa neno kuchelea limetumika kuonyesha kuogopa. Hapa Bwana Kabwe anasema wamechelea umma, hali ya kuonyesha kwamba wameogopa umoja umechelea umoja wa wana madongo poromoka. Licha ya kwamba hawa wanaotaka kunyakua wako na pesa, lakini umoja wa madongo poromoka umewatishia pia vile vile. Huu ni ukurasa wetu wa 5. Ni ukurasa wa 5. Wacha tuendelee kuangalia jambo gani liliendelea. Alijibu Kabwe, hawa wana nini wanachokichelea? Hawa wana kitu gani wasichoweza kukifanya? Hawa wanajali nini kuhusu maskini kama sisi? Alijibu Bisaruti. Kwa hivyo mhusika wa tatu ni Bisaruti. Ni Bisaruti. Alijibu Bisaruti ambaye anawapiku wanawake wote kwa hoja. Swala la nguvu swala si nguvu, kwani sisi tunajua hatuna nguvu kuwashinda wao, lakini sheria iko upande wetu. Alijiingiza tena Kabwe. Kwa hivyo hapa Bisaruti anazungumzia kwamba umoja wetu ndio nguvu yetu. Kwa hivyo hakuna vile wanaweza kutunyanyasa kama tutakuwa pamoja, kama namna siafu wanavyopigania jambo moja kwa pamoja. Lakini hapa Bwana Kabwe anapinga kauli hiyo kwa kusema kwamba wao watatumia haki. Wacha tuendelee. Sheria gani imo mikononi mwetu? Aliuliza Mzee Mago. Sheria kila siku imo mikononi mwao. Kwa hivyo sheria haiko kwa hawa maskini, na kama sheria ipo basi inawatetea matajiri. Hawa wategemee tu umoja wao. Kimya kilikuja kujiweka hapo kwa kitambo cha haja kabla hakijaondolewa tena na msemaji. Mara hii Kabwe ndiye alikiondoa kimya hicho. Akasema hivi, sisi hatutaki ugomvi wala vita nao. Tunataka suluhisho la haki tu. Kwa upande wetu, hebu na wao wapime. Tukiondoshwa hapa, tutakwenda wapi? Hapa jijini. Kwa hivyo umoja wao ndio utaweza kuwatetea kuendelea kuishi pale. Hilo swala ni letu, si lao. Wao hawatajiuliza swala kama hilo kamwe. Alijibu Bifambo. Kwa hivyo mhusika wa 4 hapa ni Bifambo. Bifambo anasema kwamba hayo yote Mzee Kabwe anayoyazungumzia hawa hawajali bwana. Umoja wetu ndio utatufanya sisi tuweze kuishi madongo poromoka. La sivyo, kama kila mtu atakuwako na wazo lake, hapa tutafanya nini? Tutaumia. Wacha niendelee. Tufanye nini basi? Alilalamika Kabwe, aliyeshindwa kujua nini la kufanya. Tutumie umoja wetu. baada ya Bwana Kabwe kushindwa na hayo yote, kuna kauli pale nasema tutumie umoja wetu. Hii kauli ilitolewa na nani? Wacha nikueleze. Tutumie umoja wetu, uwe ndio nguvu zetu, uwe nguvu zetu. Huo umoja wao utakuwako silaha kwao. Ndani ya umoja wetu kusiwe na kuchoka mpaka tupate haki yetu ya kubaki hapa maisha, au tupewe fidia inayomstahiki kila mmoja wetu, ndiyo tuhame. Kwa hivyo huu umoja wetu ndio utawafanya waishi pale. Umoja utawafanya wana Madongo tutumie neno wananchi, wa Madongo poromoka, kuishi sehemu walio au waweze kupata fidia stahiki. Fidia ambayo itawawezesha kuhama Madongo poromoka. Kwa hivyo umoja wao kama utakuwa kooni wa halali, ni wa haki, hakuna wengine ambao ni wanafiki kati yao, basi utawawezesha wale wanaotaka kunyakua pale ile ardhi ya Madongo poromoka kuwatishia. Kwa hivyo umoja wao utawasababishia wana Madongo poromoka kuishi papo wanapoishi, na kama lazima waondolewe pale, basi watapewa fidia ambayo itakuwako inaingiana sambamba na malipo stahiki, ambapo wataweza kuondoka ile sehemu ambayo imekodolewa macho na matajiri. Hapo ndipo tumeona umoja wa wana Madongo poromoka. Halafu tuangalie mwishoni mwa hii hadithi, tudhihirishe zaidi umoja wao. Je, uliweza kuzaa matunda kama anavyotueleza mwandishi kupitia hawa wahusika wanne? Mwandishi anaendelea na kusema ya kwamba fujo hazitatuhamisha hapa panapo ardhi yetu. Hapo katika huu ni ukurasa wa 9 kwanza. Kumradhi, huu ni ukurasa wa 8, ukurasa wa 7 hadi wa 8. Halafu katika ukurasa ule wa 10 pale tunaona unasema hivi: fujo hazitatuhamisha hapa panapo ardhi yetu. Kwa hivyo fujo za kina nani? Za matajiri. hazitaweza kuwahamisha wana madongo poromoka ambao wako na umoja wa dhati. Wako na umoja wa dhati na si uoga, na si uongo. Baada ya wiki 3 za vurugu hilo, vibanda mshenzi vya madongo poromoka viliota tena hapo kama uyoga. Kwa hivyo hapa ni ukurasa wa 10. Halafu wanasema wiki 3 baadaye umoja wao uliweza kuvijenga upya vibanda vyao. Hapo ni ukurasa wa 11. Kwa hivyo tumedhihirisha bayana kwamba huu umoja ambao mwandishi aliuzungumzia katika maudhui yake kwenye hadithi fupi ya Tumbo Lisiloshiba hatimaye ulileta mafanikio, na vibanda vile ambavyo vilikuwa vimesambaratishwa pale awali na matajiri waliokuwako na uchu wa kuweza kunyakua ile ardhi viliweza kuota tena kwa safari hii kwa fujo zaidi. Hadi hapo ndio nimefika mwisho wa kipindi chetu cha leo. Tutakapokutana tena tutaangalia sifa za hawa wahusika ambao mwandishi ameweza kuwatumia kufanikisha hadithi yake fupi katika hiki kitabu kiteule cha Tumbo Lisiloshiba. Hadi hapo tutakutana tena katika kipindi kingine, sio mwingine bali ni wako Mwalimu Konzi Nzaka nikisema kwaherini.
Manifested Publishers Limited is a research and teaching center that specializes in the production of learning materials and private online tuition for primary, secondary, tertiary, and university education. Sign up at www.manifestedpublishers.com. Fill in the required credentials, full name, email, phone number, and password. Click on Sign Up. Enter the code received on your phone or email address for verification of your account, then proceed by clicking on Confirm button. Your account is ready for use and you can watch some free videos before you purchase. To get access to complete videos, use the following steps to buy. Click on View All Courses. Select the course you want to subscribe to. Click on the subject you want. Click on Buy this subject. The selected subject will be added to cart. Place or hover the cursor on cart or total amount and click on Checkout Now to proceed. Click on Lipa na M-Pesa and proceed to pay. To access your lessons, place the cursor on your name, then click on Subscriptions. To download videos for offline studying, click on Watch Offline. Download the Manifested e-learning desktop application depending on your computer operating system. Install the application on your computer. Sign in on your downloaded app using the credential used during registration. Place your cursor on your name, then click on Subscriptions. Click on the subject you purchased. On the top right window, click on Download for offline viewing. Click on Go to Course. In your new window, click on the first topic, Lesson 1. Downloading process begins automatically. Thank you for choosing to study with us. For more information, you can call us on 0724 173845.
Welcome to Manifested Publishers.
Hello learners, my name is Stephen Kariungi. Welcome to today's biology lesson. Our topic of discussion is sexual reproduction in plants. And today we are continuing our study on pollination. So today we are going to look at the second agent of pollination, and that is wind. So we are going to look at adaptations of wind pollinated flowers. And these wind-pollinated flowers are also known as anemophilous flowers. So in this case, we are saying that these flowers have special adaptations that enable wind to be an agent, to be an effective agent of pollination. Now, one of the adaptations is that these flowers are small in size, whereby petals may be or may not be absent. There are flowers that are very inconspicuous. You cannot easily notice them. And these are the flowers, for example, that we find in the grass family. Yeah? If you look at the flowers in grass, they are very, very small. Their petals are very small and very inconspicuous. You cannot easily notice them. So we are saying that flowers are small with small and inconspicuous petals or bracts or inflorescence. So these flowers may exist, some as petals, some as bracts, some as inflorescence that are small and inconspicuous. So they are not very easy to identify. Now, another feature is that since these flowers do not need to attract the wind, because the wind will just come about, they have no nectar and are not scented. They are not scented. And therefore, they do not need to attract the agent of pollination. Which in this case is wind. The other characteristic or the other adaptation is in their anthers. Their anthers are large. And loosely attached to a flexible filament. They are large and loosely attached to a flexible filament to allow them to be swayed by wind. So their anthers are large, loosely attached to a flexible filament so that they are easily swayed by the wind, so that the wind can collect the pollen grains. Swayed by the wind to collect pollen. How are the pollen grains themselves? The pollen grains are small. They are small, light, and many. To allow them float in air during transportation. To allow them to float in air during transportation. That's why they need to be very light, very small, and many, because some of them will be lost along the way. The stigma is also large. Feathery or sticky to collect pollen grains, floating in the air. So their stigma are large, they are feathery, or some of them are sticky, so that once the pollen grains touch them or get into contact with them, they will just stick, so that now pollination will be enhanced. So basically, those are some of the adaptations that are commonly found in wind pollinated flowers, also known as anemophilous flowers. The other thing that we are going to learn are the features and mechanisms that hinder self-pollination and self-fertilization. The features and mechanisms that hinder self-pollination and self-fertilization. So what happens here, there are some features that exist naturally to ensure that self-pollination does not take place. And if self-pollination does not take place, then self-fertilization cannot take place. Which are these features? Now, one of those features are the hermaphrodites and monoecious plants. Hermaphrodites are those flowers that have both sexes. And monoecious plants are those plants that have flowers having both sexes. So these hermaphrodites and the monoecious plants, they have some natural features such as the scent, bright color, large petals, conspicuous petals. So those natural features ensure that self-pollination does not take place because they encourage cross-pollination. They encourage insects to come and act as an agent of pollination. So in other words, we are saying that they encourage cross-pollination. So we are saying that they have features such as brightly colored petals, and conspicuous petals. They are scented to attract insects and hence encourage cross-pollination. So we are saying that those features, they encourage cross-pollination at the expense of self-pollination. So in the process, they hinder self-pollination. So the fact that they are able to attract insects by their brightly colored petals, conspicuous petals, and their scent, and also even the nectar, you'll find that they will encourage more cross-pollination than self-pollination. Number 2 is what we call self-sterility or incompatibility. Self-sterility or incompatibility. This is whereby when the pollen grains land on the stigma within the same plant, they cannot germinate pollen tubes. They cannot germinate pollen tubes because they are similar. They are genetically identical to the other parts of that plant. So they are generally incompatible with the stigma of the same plant. And therefore, they will not germinate pollen tubes, and therefore there will be no self-pollination. So self-sterility, we are saying that pollen grains are sterile, i.e. cannot germinate pollen tubes on the stigma of the same plant. So this discourages self-pollination. And encourages cross-pollination. So basically what we have learned today, we have learned the adaptations of wind-pollinated flowers, what we also refer to as anemophilous flowers. The adaptations are, their flowers are small, very small and inconspicuous petals or bracts or inflorescence. They have no nectar and also are not scented because they don't need to attract anything as an agent of pollination. The wind is usually there most of the time. Their anthers are large and loosely packed or loosely attached to a flexible filament, a filament that is very flexible to allow them to be swayed by the wind so that the wind can be able to obtain the pollen. The pollen grains themselves are light, very light. They are small in size. They are many so that they can float in the air during transportation. The stigma is large, feathery or sticky so that the pollen grains can stick. Those pollen grains that are floating in the air, once they come into contact with the stigma, they will just get attracted. You can also mention here that that the stigma hangs outside the petals. Of course, that is to also encourage the collection of pollen. We've also learnt about the features and mechanisms that hinder self-pollination and self-fertilization, the factors that ensure that self-pollination and self-fertilization does not take place. We've seen hermaphrodites and monoecious plants, and these ones, they have special features that encourage cross-pollination. Brightly colored and conspicuous petals, the fact that they have nectar and they are scented encourages cross-pollination. Number 2, we've seen self-sterility or incompatibility, whereby the pollen grains are sterile to the stigma of the same plant, and therefore it cannot germinate the pollen tubes. So we are going to stop there, and we'll have a short assignment on what we have learned. So the assignment for today, the first question, state and explain 5 adaptations of wind-pollinated flowers. Number 2, state and explain 2 features that hinder self-pollination and self-fertilization. So we're going to meet next time. Goodbye.
Hello learner, my name is Dickens. So today we want to proceed by looking at salts, and today we want to look at solubility of salts, having defined a salt. So we said a salt is a compound formed when hydrogen ions from an acid are wholly or partially replaced by a metal ion. So today we want to look at how do salts behave when they are dissolved in water. So we want to do that by looking at a simple experiment here. So we have experiment. So I'll give you the procedure. So the first thing you do, you label procedure number 1, label 4 test tubes. You label them as follows, label them 1, 2, 3, and then 4. Then secondly, you put a small quantity of sodium sulfate in tube 1. Then the next one, sodium carbonate in tube 2, sodium nitrate in tube 3, and sodium chloride in tube 4. So having labeled the 4 test tubes, so you take the first test tube, you put sodium sulfate. The second test tube, you put sodium carbonate. The third test tube, you put sodium nitrate. And the fourth test tube, you put sodium chloride. Then number 3, you add about 20 cubic centimeters of water to each test tube, and shake. So we are simply shaking well to make sure that the salt dissolves. If it does not dissolve, you warm. Of course, you're warming using some source of heat. Then number 4, you repeat the procedure using potassium sulfate instead of sodium sulfate, potassium carbonate instead of sodium carbonate, potassium nitrate instead of sodium nitrate, and lastly potassium chloride instead of sodium chloride. So you just repeating the procedure. You put in a test tube and then you add water, then you shake. Number 5, repeat the process using samples of different salts, and then after which you record your results in the table below. So we are saying for those salts which will dissolve, you'll put a tick. For the salts which will be insoluble, you'll put an X. So put a tick, this mark for soluble ones, and X for insoluble salts. So learner, this is how our table will look like. We are having a table of the results of solubility of salts. So our table will look okay. So we have our table there showing us the salts we are dealing with. We shall put them into the 4 categories. We shall have the sulfates, carbonates, chlorides, and nitrates. So our first salt here can either be potassium sulfate or potassium carbonate, potassium chloride, potassium nitrate. So these are the ones we are dissolving in water. Then we shall have the salts of sodium. We shall have sodium sulfate, sodium carbonate, sodium chloride, sodium nitrate, etc, etc. So these are the salts that we are dissolving in water. So when you dissolve these salts in water, we have said from the experiment, the ones which will dissolve, you'll put a tick. The ones which will be insoluble, you'll put an X. From the procedure, remember we have mentioned somewhere that if the salt is insoluble, then we warm. So we are going to realize that we have some salts which dissolve on warming. So these are the expected observations. If you dissolve potassium sulfate in water, the salt is going to be soluble. So for that case, you put a tick. The next one is potassium carbonate. So if you dissolve potassium carbonate in water, potassium carbonate is also going to dissolve. So we put a tick. The next one is potassium chloride. So if you dissolve potassium chloride in water, you'll realize that potassium chloride is a soluble salt. So we put a tick. The same applies to potassium nitrate. So potassium nitrate is also soluble. So we are through with the first class of potassium salts. The next one, we are going to look at the salts of sodium. So we are going to have sodium sulfate, followed by sodium carbonate. Then we have sodium chloride. Then we are going to have sodium nitrate. So observations, we are saying if you dissolve sodium sulfate in water, the salt is soluble. Also, the same applies to sodium carbonate. Sodium carbonate is also soluble. It also applies to sodium chloride, it's soluble. And then lastly, sodium nitrate. So we can see the salts of both sodium and potassium are soluble in water. So the next one is calcium salts. We have calcium sulfate, calcium carbonate, calcium chloride, calcium nitrate. So how do they behave when they are dissolved in water? So we start by calcium sulfate. For the case of calcium sulfate, we'll realize that calcium sulfate, when you put in water, part of it will dissolve and then some of it will remain. And for that reason, we are saying that calcium sulfate is a salt that is slightly soluble. So here, for calcium sulfate, we say this one is slightly soluble. So if you dissolve in water, not all of it will dissolve. Some of the salt will remain, and for that case, we say calcium sulfate is slightly soluble. When it comes to calcium carbonate, if you put calcium carbonate in water, you'll realize that calcium carbonate is insoluble. And for that case, we put an X. So X means it is insoluble in water. Next, we have calcium chloride. If you dissolve calcium chloride in water, you'll realize that calcium chloride is a soluble salt. So you put a tick. Then the last salt of calcium is calcium nitrate. Calcium nitrate dissolved in water, it's a soluble salt, and therefore our correct observation is there is a tick. Next, we have the salts of magnesium. We have magnesium sulfate, magnesium carbonate, magnesium chloride, magnesium nitrate. So these are the expected observations. If you dissolve magnesium sulfate in water, it's going to dissolve. Therefore, we put a tick. Magnesium carbonate dissolved in water, it will not dissolve. And for that case, we are saying magnesium carbonate is insoluble. So we put an X. Magnesium chloride, it's a soluble salt. So we put a tick. Magnesium nitrate is also a soluble salt. Therefore, we put a tick. So those are the salts of magnesium. Next, we come to the salts of aluminium. We have aluminium sulfate. If you dissolve aluminium sulfate in water, it's going to dissolve. And for that case, our observation is we are going to put a tick, meaning aluminium sulfate is a soluble salt. Next, we have aluminium carbonate. So learn, I want us to understand that aluminium carbonate, a salt by the name aluminium carbonate does not exist because the salts of aluminium normally hydrolyze in water to produce an acidic solution. And for that case, for this observation, we are going to put a dash, meaning aluminium carbonate does not exist. Because of that reason, that aluminium salts hydrolyze in water to produce an acidic solution. So therefore, we are putting here a dash because aluminium carbonate as a salt does not exist. So next we move to aluminium chloride. So if you dissolve aluminium chloride in water, it's going to dissolve. Therefore, we put a tick. We have aluminium nitrate, our last aluminium salt. So aluminium nitrate, if you dissolve in water, it's going to dissolve. So you put a tick. Next, we have the salts of zinc. We have zinc sulfate, zinc carbonate, zinc chloride, and zinc nitrate. Observations. Zinc sulfate is a soluble salt, so we put a tick. If you dissolve in water, zinc sulfate will dissolve. Zinc carbonate, if you dissolve zinc carbonate in water, the salt will not dissolve, and for that reason, we are going to put an X, meaning zinc carbonate is insoluble in water. Then we have zinc chloride. Zinc chloride is going to dissolve, therefore we put a tick. Lastly, we have zinc nitrate. Zinc nitrate dissolved in water, it's going to dissolve in water. Next, we have the salts of iron. We have iron sulfate, iron carbonate, iron chloride, and iron nitrate. So these are the expected observation. Iron sulfate dissolved in water is going to dissolve, therefore we put a tick. Iron carbonate dissolved in water, the salt is insoluble, therefore we put an X. We have iron chloride. Iron chloride is also going to dissolve in water, therefore we put a tick. Then we have iron nitrate, in water. It's a soluble salt, so you put a tick. Next, we have the salts of lead. We have lead sulfate, we have lead carbonate, lead chloride, and lead nitrate. All these are examples of salts. We have only put them into categories depending on the anion that is there. So we have 4 anions. We have sulfates, we have carbonates, we have chloride, and we have nitrates. Now, lead sulfate dissolved in water, the salt is insoluble. Therefore, we put an X. Lead carbonate dissolved in water, the salt is also insoluble. So therefore, we put an X. And then we have lead chloride. Lead chloride, if you dissolve it in cold water, it will not dissolve. So how do you make lead chloride to dissolve? You make it to dissolve by simply warming the mixture. So therefore, we are saying that lead chloride will dissolve in hot water. So here we are saying soluble in hot water. And then we have lead nitrate. Lead nitrate dissolved in water, the salt is going to dissolve. Therefore, we put a tick. Next, we have the salts of copper. We have copper sulfate, we have copper chloride, copper carbonate, copper chloride, then copper nitrate. Expected observations. Copper sulfate, if you dissolve copper sulfate in water, it's going to dissolve. Therefore, we put a tick. Then the next one we have copper carbonate. Copper carbonate in water, it's going to be insoluble. Therefore, we put an X. Next, we have copper chloride. Copper chloride dissolved in water. The expected observation is going to be insoluble. Therefore, we put an X. And then lastly, we have copper nitrate. So copper nitrate dissolved in water, it's going to be soluble in water. Therefore, we put a tick. Lastly, we have the salts of barium. Barium, we start by barium sulfate. Barium sulfate, when it's dissolved in water, it's going to be insoluble. And for that case, our table, we're going to put an X, meaning barium sulfate is insoluble in water. Next, we have barium carbonate. If you dissolve barium carbonate in water, it's going to be insoluble. Therefore, you put an X. Next, we have barium chloride. Barium chloride, this one is soluble in water. Therefore, we put a tick. And then lastly, we have barium nitrate. So barium nitrate dissolved in water, the salt is going to be soluble. So, learner, we are saying these are the expected observations from the experiment we have mentioned earlier. So, having said that, I now want us to look at a summary. From the table, you can see that both potassium and sodium, you can see their salts. Potassium sulfate, potassium carbonate, potassium chloride, potassium nitrate, all these are soluble. The same applies to sodium, sodium sulfate, sodium carbonate, sodium nitrate, and sodium chloride. So, in summary, we are saying that all salts of both sodium and potassium are soluble in water. That's the first observation we can make from this table. The second observation, learner, we are saying, if you look at this column of nitrates, you should be able to notice something about nitrates. Remember, we have said where there is a tick, it means the salt is soluble in water. So, our second observation is what? That all nitrates, any salt that contains a nitrate, we expect it to be soluble in water. That is observation number 2 from the table. Then the third point, we can get it from the column of carbonates. Apart from potassium carbonate and sodium carbonate, you realize that the other carbonates are insoluble. So we are saying our point number 3 is this, that all carbonates are insoluble except the carbonates of sodium and potassium. These two are insoluble. Our fourth point, conclusion, is obtained from the column of sulfates. You can see, apart from lead sulfate and barium sulfate, the other sulfates are soluble in water. So we are saying that all sulfates are soluble in water with the exception of lead sulfate and barium sulfate. And lastly, our conclusion point is on chlorides. You can see, apart from lead chloride, we are saying the other chlorides are soluble in water. Of course, we have said lead chloride is soluble in hot water. So, learner, we want to come with a conclusion basing on those observations that we have seen there. So, conclusion, our first point. Conclusion, our first point is as follows. That all salts of sodium, potassium are soluble in water. All salts of sodium, potassium, so we can add ammonium because ammonium is another example of a positively charged ion, and ammonium are soluble in water. Think of any salt that has the word sodium, that has the word potassium, that has the word ammonium. Sodium sulfate, potassium carbonate, ammonium nitrate. So long as it has these three cations, then that salt will be soluble in water. That's number one. Number two, all nitrates are soluble in water. We can see that from the table earlier on. Any nitrate you can mention, sodium nitrate, potassium nitrate, magnesium nitrate, any nitrate you think of, then if you dissolve it in water, that nitrate will be soluble in water. Our third point about conclusion is coming from carbonates. We have said earlier that all carbonates are insoluble. That's the point we are repeating, that all carbonates are insoluble. But there is an exception. Remember earlier on we have said, the first point we have said is that any salt of sodium, potassium or ammonium is soluble. But here we are saying all carbonates are insoluble. That means we have some carbonates which are soluble. And these are the carbonates of sodium, potassium, ammonium. So we are saying all carbonates are insoluble except carbonates of sodium, potassium, and ammonium. So we have said earlier on that from the conclusion point number one, potassium, sodium, and ammonium salts are soluble. But here we are saying all carbonates are insoluble. That means the carbonates of these three, sodium, potassium, and ammonium, if you put them in water, they'll dissolve in water. So we are saying if you put sodium carbonate in water, it will dissolve. Put ammonium carbonate in water, it will dissolve, as well as potassium carbonate. Our fourth point of conclusion is coming from sulfates. We are saying that from the table we said earlier on that all sulfates are soluble. So that's the point we are emphasizing, that all sulfates are soluble. but we mentioned the ones which are insoluble. We said barium as well as lead what? Sulfate. So these two are insoluble. So otherwise the rest are insoluble. So we are saying all the sulfates are soluble except barium sulfate and lead sulfate. But remember we said calcium sulfate is slightly soluble in water. So it's good we also mention that one, that calcium sulfate is slightly soluble. Calcium sulfate is slightly soluble. Then our last point of conclusion is coming from chlorides. So we said from the table, chlorides are, most of them are soluble. So that's the conclusion we are coming up with, that all chlorides are soluble. All chlorides are soluble. And remember we have said, we gave an example of the one that is soluble in hot water, and that was lead chloride. So it's good we mention that lead chloride is soluble in hot water. So you can only make lead chloride to dissolve when you warm the mixture. So Lana, we are saying that from these 5 points, the salts of sodium, potassium and ammonium are soluble. Our second point is that all nitrates are soluble. Our third point is carbonates. All carbonates are insoluble. All carbonates are insoluble. All nitrates are soluble. And then all sulfates are soluble. All chlorides are soluble. We have given exceptions. So we have come to the end of our lesson. It's good for your revision. You try and answer these questions. So I want you to try these questions. So the first question is identify the cations. Identify the cations that form. Identify the cations that form soluble salts. That's our first question. Our second question is comment on the solubility. Comment on the solubility of sulfates. Give a brief comment on sulfates. Give a brief comment on chlorides. Give a brief comment on carbonates. And give a brief comment on nitrates. And that will be the end of our lesson for today. I want to thank you for being a good student, and I wish you the best.
Enroll your child for the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Hello learners, we are here again today to learn about vectors. Now we've already had lesson 1 and lesson 2 in vector 1, that is vector 1. Now in the last class we were able to look at addition of vectors. We were able to look at addition of vectors. we were able to look at subtraction of vectors and in essence what we call zero vector. And we were also able to look at multiplication of vectors by scalar quantities. Multiplication of vectors by scalar quantities. So this is the work we looked at last time. Today I want us to move ahead today and look at one, what we call column vectors. Column vectors. Two, we will look at very fast, again, position vectors. So we look at column vectors, we look at position vectors, and then lastly for today, we look at what we call magnitude of vectors. So this is the work we are going to look at today. Now I want you to realize, learners, that all these materials we are looking at, addition, zero vector, multiplication of vectors, column vectors, position vectors, and magnitude of vectors, everything in vector 1, we are actually looking at everything in vector 1 in what we call in 2 dimension. It is important to note this because we look at some of this information again when we'll be dealing with vectors in Form 3, and in that instance we'll be looking at these items in what we call 3 dimension. So I want us to start with column vectors. Now, it is important to know what to expect when we are talking of column vectors. Now, for example, when you want to give the value of vector xy like that, you can write the value of xy, say any numbers, 2, 3. Now, vectors written in this form, this vertical form, is what we normally say that a vector has been written in column form, and therefore these are the column vectors. So we can give several examples. For example, vector AB, you can write that as, say, scalar 1, 2. Now, it is important to note these are but examples. After our calculations, we can get different values, so these are but examples. Now, in each instance, I want us to realize that the first value at the top represents the x coordinates. The first value represents the x coordinates, and the second value represents what we call the y coordinates. The y coordinates. The first value represents the x coordinates, and the second value represents what we call the y coordinates. I want us to move ahead and see what we call column vectors when we look at a Cartesian plane. I want us to move ahead and look at what we call column vectors when we look at a Cartesian plane. Now, in a Cartesian plane, say that way, that will be y x-axis. So this is the y-axis. Always show the arrows and always write y-axis and x-axis. Don't assume. We can have a vector here, say vector gf. We can have a vector, say vector gf. Now in vector gf, we can give that arrow that way. I want us to get the coordinates of vector gf. Now, suppose this was 1, and here we have, say, 1, so that this can be 2, 3, 4, 2, 3, 4, 5. Now, it is important to realize we are not accurate this is a sketch. Now, looking at this, for example, point G. Point G is directly above 1 on the x-axis, and therefore you can give it coordinate 1 for x, and you put a comma there. And then it's directly next to 1 when you look at the angle between point G and 1 on the y-axis. There's a right angle. So you can say that the value of G on the y-axis is 1 again. Now for F, you can read it direct like that and say that F is directly above 4 in the x-axis. So the coordinate of F in respect to x is 4. You put a comma. And F is directly adjacent to 5 that way. So you give 5 there, give 5, give 5. So in other words, we can say that we are talking of vector G, F, where G has coordinates 1, 1, and F has coordinates 4, 5. Now, we've agreed that to get vector of these two places, to get vector of GF, then it means we are looking at the displacement between G and F, but in the direction from G up to F. So in that instance, we can therefore say that we look at the change in units of x-axis. So at G, we are talking of 1, and at F, we are talking of 4, meaning the change between this G and F on the x-axis are actually 1, 2, 3 units. And therefore, we can therefore say that GF, in respect to x-axis, we've had a change of 3 units. And in respect to y-axis, we can have change from 1 up to 4. So that will be 1 unit between 1 up to 2. The second unit between 2 up to 3. The third unit between 3 up to 4. And the fourth unit between 4 up to 5. So we can therefore say that from 1 up to 5 on the y-axis, we've had a change of 4 units. So the change in y-axis between G and F is therefore 4 units. Now, writing this, we can therefore write this vertically so that we end up with the point, the vector GF being 3, 4. In this instance, learners, we shall have written GF as a column vector. In this instance, we shall have written GF as a column vector. Allow me to give more examples so that we can understand better. Allow me to give more examples. So, like I've said, let me give you at least more examples to illustrate this, Now, you can be given 2 column vectors and asked, for example, to get the displacement between those vectors. For instance, you can be given vector AB and told that vector AB is 2, 3. Now, by now, I believe we already realized that this is a column vector. And you can also be given vector AC and told that vector AC is 1, 4. Now, from what we learned yesterday, addition of vectors, you can be asked to get vector AC. Now, getting vector AC in this instance, like we learned in the last class, we agreed that vector AC would be the displacement between A up to C. That is, you can have the vector A, B, C like that, such that vector AB, we already have, then vector BC, such that for us to get vector AC, we agreed it should be AB plus BC. So I'm bringing this forward so that we can see on how we can add column vectors. So in this instance, you will say that vector AB is given by column vector 2, 3, plus vector BC, this should have been BC so that it makes sense. BC would be 1, 4. Now, with this, we had agreed that the upper scalar units actually refer to the x units, and the lower scalar units, that is 3 and 4, actually refers to the y units. So in this instance, you will add the upper units on their own, so that will be 2 plus 1 to give us 3, and then 3 plus 4 to give us 7. Now, in the same breath, still you can be given column vectors and asked to subtract them. Still you can be given column vectors and asked to subtract them. For example, you can be given column vector 4, 9 and asked to subtract column vector 2, 6. So in this instance, like we've just said before, you will subtract the x units, that is 4 minus 2, and then you'll subtract the y units, that is 9 minus 6, like that, such that what you'll end up with is 4 minus 2 to give us 2, and 9 minus 6 to give us value 3. So in this instance, you've realized that we have used column vectors and applied it when it comes to subtraction and also addition of vectors. It is important still to know that column vectors is very useful when you are doing vectors, and still you can be asked to use it even during multiplication by scalars. For instance, consider 2 vector AB minus 3 vector CD, where vector AB is 7, 14 and vector CD is 0. Let's not give it 0. Let's give it is, say, 1, 3. Now, in that instance, I am trying to refreshen our minds how we can apply multiplication of scalars to column vectors. We will end up saying that we now have 2 multiplied by AB, but AB here is 7, 14. Now, learners, let us begin. There are situations where learners have been putting a sign here, division sign. This will now not show a vector. This is a fraction. So whenever you are dealing with vectors, make sure that you just have a value of x units and also value of y units without any sign in between. So minus 3 vector CD, and CD there is 1, 3. Now I want us to be keen to see how we multiply when we are using scalars to multiply column vectors. So in this instance, we'll talk of 2 times 7. We'll multiply every individual letter, so every individual unit. So this will be 2 times 7, which is 14, 2 times 7. Then we'll have 2 times 14, which is 28. In other words, the vector 2AB now becomes 1428 minus 3 times 1, which is 3, and 3 times 3, which is 9. So from there, our subtraction is the normal subtraction, like what we've been doing before. So we will expect here to have 14 minus 3, which is 11, and then 28 minus 9, which gives us 19. So that would be our answer for vector 2AB minus vector 3CD. So having looked at that, I think we've exhausted what you are supposed to look at column vectors, and we can look at what we call position vectors. So let me just clean here so that it's possible for us to look at the position vectors. Let me just clean all of it like that. Let me just clean there. So position vectors. Now in lesson 1 and lesson 2, we touched position vector a little bit, though we didn't go deep into it. But what we said is that position vectors start from the origin of a Cartesian plane. So for instance, if you draw a Cartesian plane like that, this is y-axis, and then this is x-axis. That is a 2-dimension Cartesian plane. We can draw, now we know this is the origin, so these coordinates are 0, 0. So all vectors starting from the point 0, 0 are called position vectors. For instance, you can have a vector like that to point, let's say this is origin O to point P. Let's give P the coordinates, 4, 5, where 4 is on the x-axis and 5 is on the y-axis. Now with this, we can get what we call vector OP. We can get it. Now, since we've looked at column vectors, it now should be easy for us to get. Vector OP should be P minus O from what we have. And this is basically 4, 5 for P, minus O here is 0.0, 0. So when we look at this vector, therefore, we can say that vector OP is equal to 4, 5. Now, vectors that start from the origin O are normally called position vectors. So in this instance, vector OP here is a position vector, and normally we simply represent position vectors by the last alphabet. For example, if it is OP, you simply call it vector P using small p instead of writing OP. So instead of saying vector OP, we can simply say we have vector P, this is small p, is equal to 4, 5, which is column vector of position vector P. Now, in general, therefore, let's just rub here. In general, therefore, we can boldly say that anytime you have any position vector, say OB, then you can write its position vector as vector B. If you have, say, OD, then its position vector is simply vector D, small d. If you have, for instance, OW, then its position vector is simply W, like that. I want you to try a small assignment later. If you're given, say, vector OJ, I want you to tell me what will be its position vector, letter that will represent it. You're given OQ. I also want you to tell me a letter, how you'd represent it using only one letter. Only one letter. Now, when you're talking of position vectors, the coordinates of the last point is normally important. For instance, in this case, vector OP, we went the long way, but since at the origins there's 0, 0, normally you can just pick the last coordinates, write them in column form, and that will give us what we call the position vector of that number. So having looked at that, I think we can move straight away, because this knowledge of position vectors and column vectors will be important in the next thing we are going to learn. So I want us to look straight away at what we call the magnitude of a vector. 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 So we can do that. Now, we agreed when we were starting the first lesson that whenever you're talking of magnitude of a vector is the same as looking at the length of that vector. The magnitude of a vector is normally the same as looking at the length of that vector. Now, I want us to consider a point. Let's say this is y-axis, and this is x-axis. So that is y-axis, and that is x-axis. I want us to consider a point, say point EF, those 2 points, and let's say this is a vector. Now, from these 2 points, I want us to talk of the coordinates. Let's give them coordinates. We can give them coordinates of E2, 3. Can give them coordinates of E2, 3. And F, let's give them coordinates of, let's give F the coordinates of 5. Let's give X the coordinate of 5, 7, that way. Now, looking at this, we know that we can get the length EF. But how we can get the length EF, it means that we can create a right angle triangle like that. Now, on creating a right angle triangle, this means that if this is 2, 3, it means that this point we are talking of 2, and at this point we are talking of 5. And then at this point, if we have 2, 3, it means we are talking of 3, and at F, it means that the y-axis, the y value there is 7. Now, from this, remember, it is this magnitude we want to get, and we've just agreed that magnitude is the same as length. So to get this magnitude, or the length between EF vector, we know from our knowledge of triangles that we can use a formula called Pythagoras theorem. Allow me to wipe here so that it is clearer to us. We know that we can use a formula called Pythagoras theorem so that we can get EF. Now, that theorem states that if, now let me call this point arbitrary point, say EX, let me call here X for the purposes of understanding what we are doing. Now, that formula tells us that if we take EX and square it and add XF, we add XF and square it, then the length we are getting would be the same as the length EF squared. Now, with that in mind, therefore, we can get EX. Now, EX in this instance are the displacement in the x-axis. Now, the first value of x is 2, and the last value on the x-axis is 5. So we've had a displacement of 3 units. So in this case, we can therefore call EX as 3 squared plus, now, the first value of E at y-axis is 3, and the last value is 7, meaning we've had a displacement of 4 on the y-axis, and call this 4 squared. So while working with that, we can therefore get EF squared, like that. Now, we know the value of 3 squared, so this will be 9 plus 4 squared would give us 16, and this should be EF squared. So from here, we can get 9 plus 16, which is 25, which is EF squared. It is important to realize you can start by writing EF squared is equal to 25. So to remain with EF alone, if we originally have EF squared, we can find the square root of both sides like that, such that EF squared will be EF is equal to what we are now calling 5 units. So this will be the magnitude. Now, normally when you are talking of magnitude, you denote magnitude of a vector. Say, in this instance, we wanted magnitude of vector EF. Normally, we denote magnitude of a vector by double straight vertical lines next to it, such that you create 2 lines here like this. So when you do this, you can say this is 5. So this is read as magnitude of vector EF. Magnitude of vector EF. It is also important to note that magnitude can sometimes be called the modulus. So we can call this the modulus of vector EF, or we can call it the magnitude of vector EF. Now, learners, I want us to realize something. We were initially dealing with EF as EF, and we gave the coordinates of E as 2, 3, and the coordinates of F we gave as 5, 7. It is important to know that we can get the magnitude of this without actually drawing anything on the Cartesian plane. So while working with this, first of all, for us to get the magnitude of vector EF, it will be important to get vector EF alone like that. So vector EF is the displacement between E and F. So we can use the column vectors and say this is F, which is 5, 7, minus E, which is 2, 3. From here, we can say that we will have 3, 4. Can have 3, 4. Now, from this, we can therefore say that EF modulus, the magnitude of EF, can therefore be the square root of 3 squared plus 4 squared, like that. Such that from this, we can therefore say that the magnitude of EF is equal to the square root of 25, which will give us the magnitude as 5 units. Can probably give you another example, and then from there we can now give you an assignment. Suppose you are given vector CD as 2, 7. Suppose you are given vector CD as 2, 7, and you are asked find the magnitude of CD. Then you will simply say that the magnitude of CD is equal to the square root of 2 squared plus 7 squared, which will give us the square root of 4 plus 7 squared is actually 49, which will give us the square root of 53. So from here you can use your calculators to find the value of the square root of 53. I therefore want us on finishing to leave work behind so that you can have some assignment to do. So this is the work I want you to try later so that you can check whether you are able to understand what we have done. Assignment. Find the magnitude of AB, where vector A is 2, 1 and B is 4, 5. B, where A is negative 3 and the Y value there is 0, negative 3, 0, and B is 0, 4. So that is the first question. Question 2, find the magnitude of the following vectors. Magnitude of the following vectors. So the first vector in this case should be vector AB 6, 5, and vector XY, you can work with 12, 13. So that brings us to the end of our lesson today. You'll do that assignment so that you can test yourself. Now you realize that our assignment is on magnitude, though we've worked on column vectors, we've also worked on position vectors. It is important to realize that the column vectors and position vectors are actually applied in the magnitude of vectors. So in essence, the practice we are doing here is actually still making you to do practice on column and also on position vectors. I want us to stop there for today. So we have to remember, 1, we've learned about column vectors. 2, we've learned about position vectors. And 3, we've learned about what we call magnitude, or the length or the modulus of a vector. I have been with you, Mr. Geoffrey Omondi. Allow us to stop there for today. Till next lesson. Thank you.
Manifested Publishers Limited is a research and teaching center that specializes in the production of learning materials and private online tuition for primary, secondary, tertiary, and university education. Sign up as a new customer at www.manifestedpublishers.com. Fill in the required credentials, full name, email, phone number, and password. Click on Sign Up. Enter the code received on your phone or email address for verification of your account, then proceed by clicking on Confirm button. Your account is ready for use and you can watch some free videos before you purchase. To get access to complete videos, use the following steps to buy. Click on View All Courses. Select the course you want to subscribe to. Click on the subject you want. Click on Buy this subject. The selected subject will be added to cart. Place or hover the cursor on cut or total amount and click on checkout now to proceed. Click on Lipa na M-Pesa and proceed to pay. To access your lessons, place the cursor on your name, then click on subscriptions. To download videos for offline studying, click on Watch Offline. Download the manifested e-learning desktop application depending on your computer operating system. Install the application on your computer. Sign in on your downloaded app using the credential used during registration. Place your cursor on your name, then click on Subscriptions. Click on the subject you purchased. On the top right window, click on Download for offline viewing. Click on Go to Course. In your new window, click on the first topic, Lesson 1. Downloading process begins automatically. Thank you for choosing to study with us. For more information, you can call us on 0724 173845.
Number 6. So the figure below shows the displacement time graph for a certain wave. So we want to have the wave here. This is displacement. We have time in seconds. This, as I said, is to guide us. So that's the wave. Then we have been given the following for the wave. We have been told that this point is 7.0 times 10 power negative 3 seconds. Then we've been told at this point is 3.5 times 10 power negative 3. So that is what we have, and we are told determine the frequency of the wave. So here is the question. So we've been told the figure below shows the displacement time graph for a certain wave. As we can see, we are told to determine the frequency of the wave. And we have been given time at this point and also at the other point. And we know that frequency refers to the oscillations in 1 second, or number of oscillations in 1 second. So as we can see here, how many oscillations do we have? We can calculate and see the number of complete oscillations for this wave. So we have this. This is 1, 2, 3. So we have 3 waves. That is 3 complete oscillations. 3 complete oscillations. And they are being covered in 7.0 times 10 power negative 3 seconds. So we have 3 oscillations in 7.0 times 10 power negative 3 seconds. And now that we know frequency is the number of oscillations in 1 second, we ask ourselves, what about in 1 second? How many complete oscillations, or how many oscillations are we going to have? And that will be our frequency. So we are going to have 3 times 1 divided by 7.0 times 10 power negative 3. So we can calculate this using your calculator. So we are going to have 3 divided by 7 times 10 power negative 3. So what do you end up getting? So we can write it to 2 decimal places. So we are going to have 428.57. And this is frequency, so it is 428.57 hertz. So that is what we are going to have for that 428.57 hertz. So because the number of complete oscillations here are 3 in 7.0 times 10 power negative 3 seconds. So in 1 second, we want to know the oscillations. There will be 428.57 hertz. So that will be our frequency.
Welcome to Manifested Publishers.
Hi learners, I am so delighted to have you again on this platform. Remember that you are still tuned into Manifested e-learning platform. I am Teacher Purity. So we are going to learn hygiene and nutrition activities. We are still learning the topic personal hygiene, and under personal hygiene, we are going to learn how to make personal items. Now, during our last lesson, we were discussing about some of the personal items we have. So let's quickly remind ourselves. Personal items are the things we do not share. So personal items are the things that we do not share, the things that you are not supposed to share with anyone. Sharing of personal items can make us fall sick. So sharing of personal items can make us fall sick. Sharing of personal items can make us fall sick. That is why you are not supposed to share your personal items. Now, the examples of personal items. Examples of personal items. We have a handkerchief, a handkerchief is a personal item, and we use a handkerchief to wipe our nose. So you are not supposed to share your handkerchief with any other person because you can contract diseases. Then we also have toothbrush. A toothbrush is a personal item. You are supposed to have your own toothbrush. Sharing of toothbrushes can make us contract diseases. Then we have underwear or pants. Underwear or pants. They are also personal items. You are not supposed to share your underwears or your pants with anyone. Then we have comb. A comb. Now we use a comb to make our hair. You are not supposed to share your comb. Why are you not supposed to share your comb? Because when you use your comb with another person, you can fall sick and you can even suffer from ringworms. Ringworms are some wounds that are always found transmitted through combs. So when you have your own personal comb, you'll have protected yourself from ringworms. Then we have another personal item, have a towel. Now a towel is used to wipe our bodies after taking our bath. So you are also not supposed to share your towel. Make sure that you have your own towel. We also have another personal items. You have socks. Socks is also a personal item. Then we also have a nail cutter. A nail cutter. A nail cutter is used to trim our long nails. Remember that your nails are supposed to be short and clean. And for you to maintain short nails, you are supposed to use a nail cutter. So do not share your nail cutter with a person. Make sure that you have your own nail cutter. So these are examples of personal item. We have a handkerchief, a toothbrush, underwear or pants, comb, towel, socks, and lastly, nail cutter. So for this lesson, I want us to discuss on how to make personal items. All these items here, there are some of the items that you can still make them. It is not a must for you to buy a handkerchief. You can still get something else and use it as a handkerchief. Not a must for you to buy a toothbrush. There is something else you can use instead of a toothbrush, the same to towel. So let's see, how can we make a toothbrush? How can you make a handkerchief from what we have around us? So how to make personal item. Let's see on how to make a toothbrush. You can make a toothbrush from a chewed stick. So the first one, we can make a toothbrush from a chewed stick. Now, we can make a toothbrush from a chewed stick. If you cannot be able to afford a toothbrush, do not stop brushing your teeth because you don't have a toothbrush. You can still brush your teeth with a chewed stick. You go and get a chewed stick from as a branch of a tree, then you chew the upper part and make a toothbrush out of the chewed stick. So it can still help you to brush your teeth. We can also make a handkerchief from a piece of cloth. So we can make a handkerchief from an old piece of cloth. So we can make a handkerchief from an old piece of cloth. You go and take an old piece of cloth, wash the piece of cloth, let it dry, then you cut a piece of it and use it as your handkerchief. We can also make a face towel from an old piece of cloth. we can also make a face towel from an old piece of cloth. Remember, a face towel is used to dry our face after you have washed it. So if you cannot afford a face towel, you can as well as use an old piece of cloth to wipe your face, and make sure that the old piece of cloth is clean. So this is how we can make personal items from what we have around us. Number one, you can make a toothbrush from a chewed stick. You go and get a tree branch, a small one, then you chew it and use it as your toothbrush. The second one, we can make a handkerchief from an old piece of cloth. It is not a must for you to go to the shop and buy a handkerchief. You can as well as use an old piece of cloth and make sure that it is clean. And lastly, we can make a face towel from an old piece of cloth. So this is how we can make personal items. And remember, if you have your chewed stick as your toothbrush, you are having your old piece of cloth as your handkerchief or your face towel, you are still not supposed to share it. It is still your personal item. So make sure that you are not sharing it. You know why you are not supposed to share personal items, right? Now these are some of the ways how you can make improvised materials as personal items. So try to use them, try to use some of these improvised materials back at home. You can use a chewed stick. You have the experience of how you can brush your teeth with a chewed stick. Use a piece of cloth as your handkerchief or as your face towel. So that is all for this lesson. I want us to copy some questions and make sure that you are answering them. So the questions are here, number 1 up to 3. The instructions: write true or false to answer the following questions. So you are going to write for me in the blank spaces whether it is true or false. Number 1, we can use an old piece of cloth to wipe our nose. Write for me if it is true or false. Number 2, a chewed stick is a personal item. True or false? You write for me the answer there. And lastly, a face towel cannot be made from an old piece of cloth. You write for me the correct answer there. So finish the work and make sure that you are going through your work after you have answered it. Hope to see you in the next lesson. I have been Teacher Purity.
Enroll your child for the manifested e-learning platform and see their grades grow tremendously. These videos can be downloaded to a laptop for offline viewing or viewed from a smartphone in a course-friendly format.
Hello and welcome back, learners. This lesson is a continuation of the lesson that we had last time, where we were discussing the environmental, the external environmental factors that affect businesses, and we discuss the competitors, customers, suppliers, political factors, legal factors. Then at the end of that lesson, I gave you the assignment. You're supposed to explain explain the 3 ways in which competition may affect a business. 2, discuss how political factors may influence the operations of a business. It's my hope that the assignment is done. This was assignment for the last lesson, and the topic is business and its environment. The subtopic is external environment. This lesson is a continuation of that lesson. So I want to discuss the other factors external environmental factors. So the sixth factor is the economic factors. Economic factors. Economic factors. Economic factors. Now, these are factors that influence the entire economy of a country. A business will need to monitor trends in the economy as changes may affect its operations. For example, changes in the level of prices in the economy, the changes in interest rates, the changes in inflation, okay? All this will affect the cost of products and also the cost of doing business. So performance of the economy, learners, and stability of the currency will always affect the price of goods and services that consumers are willing to buy and able to buy. Okay? Therefore, the changes in the needs and wants of consumers and the level of incomes of consumers will plays a very big role in determining the operations of the business, because we are saying the changes in inflation and so on will affect again the behavior of consumers depending on the incomes of the consumers. So business activities in an economy may also be affected by the availability of such projects or infrastructure that is put in place by the government. Okay, business activities in the economy may be affected by government investments in projects like roads, railways, communication, and so on. Because the government, at a general level, the government may build roads, may build railway systems and communication systems that will have an impact on business activities. Learners, again, the government on a national level may build roads, railway lines, communication systems. That is now looking at the economy in general or at a national level. When the government does that, then that will have a positive effect on business activities. So when you are running a business, it's important to look at the general economic environment. The general economic environment. We mentioned the interest rates, inflation rates, and the incomes of customers or consumers, and government expenditure on projects like roads, projects like railway, projects like communication systems, and so on. So all that is what we are referring to as economic factors. Economic factors. These are economic factors. Then we have social-cultural factors. Social-cultural factors. Social-cultural factors. Social-cultural factors. Social-cultural factors. These are factors that are based on people's beliefs, people's values, attitudes, opinions, lifestyles, and so on. And they may be determined by culture. These factors may be determined by a culture of the people, religion, level of education, age, ethnic background, and so on. So if these factors change, okay, then people's tastes and preferences may also change. All right. For example, people in, say, rural areas may start to have the same taste in clothing as those in big towns due to the influence of urbanization. Okay, influence of urbanization. When I was growing up as a young man, we're talking about clothing. There are some clothes that were not worn in the villages. Today, due to urbanization, people wear clothes that are worn in urban centers. Okay, so that is change. We are talking about change. So if you are in business of offering clothes, so and there is demand for these clothes that are worn in urban areas, in rural areas, then you see you also need to change, okay, so that you don't supply clothes that are no longer worn in the villages. So we are saying if these factors change, if the tastes and preferences of consumers change, then the business has also to change so as to meet the new needs of the customers. So learners, these are factors. Cultural factors. This is one word. Cultural factors. These are factors that are based on beliefs, values, attitudes, opinions, and lifestyles of the people. And they are determined by culture. Culture means the way we do things, okay? They are also determined by religion. These sociocultural factors can also be determined by education. There's a way in which education shapes people to behave in a certain way. The sociocultural factors may also be affected by age. We've mentioned ethnic background and so on. So we said if these factors change, then people's tastes and preferences will also change. Preferences means what people prefer in terms of goods and services. If you're offering goods that people are no longer buying, then it means the preferences have changed. So we say that if people's preferences change, then you need to also change the products that you produce and services. So, but you cannot change if you are not monitoring the environment, if you are not checking to see what is happening in the external environment. You need to remember we talked about research and development in our previous lessons. You need to do market research. Continuously scan the environment to see if there are any changes so that you can also adjust to meet customers' needs. These are sociocultural factors. Another factor, learners, is technological factors. Technological factors. Technological factors. Technological factors. What is technology? Technology is the application of scientific knowledge in performing work. It is the application of scientific knowledge in performing work. So a business has to consider the technological factors influencing its operations. If you are in education industry, you need to check what are the new technologies arising in that industry. If you are in manufacturing, you need to check what are some of the new machines or methods that are being used in manufacturing products. This is because technology can radically change the way goods are produced and services are provided. For example, with the advent of the internet and the new gadgets, the mobile phones, the applications, and so on, such changes have radically revolutionized the way we do things, the way we offer our services, the way we offer products, and so on. At the same time, this technology can lead to reduction in costs and improved goods and services. So technological developments can lead to creation of new markets through adoption of what we call e-commerce, electronic commerce. And this allows businesses to operate without borders, right? E-commerce allows people to transact online. Today, a buyer in Kenya can purchase goods in US and make payment instantly. And that is what we are referring to as e-commerce. So this allows business to operate without borders. Without borders. Businesses, including individuals, are able to buy or sell goods and services over the internet. Over the internet. Even yourself, we are reaching you through the internet. Okay? I no longer need to come to your house to do physical tuition. Why? Because of the internet. You can now get my services while seated at the comfort of your home. So a business should take advantage of the technological developments that may improve its operations. And I think that's what manifested publishers are doing. They're able to prepare the products so that they can reach people over the internet. So that's technological factors. There's a lot that we can say about technology and how and why a business should scan the external environment to determine to understand how it operates, to determine the emerging technologies that will help the business to offer different goods or to improve the service delivery and to improve the existing products. So the adoption of technology may bring with it problems, learners. However, the adoption of technology may bring with it problems like disruptions brought about by breakdown of equipment, mass layoffs. Those are problems. Mass layoffs of staff due to lack of necessary skills, okay, and so on. We have in other countries where staff are being laid off because robots are performing tasks that were initially performed by people. So those are some of the adverse effects of technologies. But a business, when running a business, is important for the business owners to scan the technological environment. I've explained reasons why that should happen. Then lastly, we want to discuss the physical factors. Physical factors. Physical factors. Physical factors. This is the last factor. Physical factors. What are these physical factors? Physical factors. Learners, the operations of certain businesses are heavily affected by what exists in nature. For example, businesses dealing in agricultural produce depend heavily on the existence of appropriate weather and climate. So an unexpected change in the these natural conditions may negatively affect the business. That is the climate, okay, the weather, and so on. For example, harvesting of tea, coffee, maize, and so on in Kenya are greatly affected by what we call incidents of frosts, which damage tea and coffee plantations. So some governments may also, other than these factors, the government may also pass protective laws that limit the availability or the availability of these resources, or the ability of businesses to exploit natural resources such as minerals, forests, and so on. The government can put laws in place that limit logging, cutting of trees, or exploiting certain natural resources. So if you are in an industry where you depend highly on natural resources like trees as a source of raw material, you see that again will affect, negatively affect the business. So such laws are aimed at protecting natural resources. When the government puts in place such laws, the purpose is to protect natural resources and the inhabitants of surrounding areas. Okay, so but businesses that face such restrictions would find it very difficult to remain in operation. So you see, this is an external environmental factor which the business may not have control over. When the government passes law, then you have no option but to obey. The government says there is no mining in a certain area, then you can't mine because of the government's interest is to protect, in such a matter, is to protect such resources. So these are physical factors. I've mentioned the weather, I've mentioned the climate, and so on. Climates are not constant. They do change because of certain factors like global warming and so on. So those are physical factors. So learners, we have discussed 1, 2, 3, 4, 5, 6, 7, 8, 9 external business environmental factors. These are factors that business may not have control over, but yet they influence the operations of the business, either negatively or positively. So the first one is competition. Number 2, customers. Number 3, suppliers. Number 4, political factors. Number 5, legal factors. Number 6, economic factors. Number 7, socio-cultural factors. Number 8, technological factors. Then lastly, number 9, physical factors. So I want you to go through this video together with the previous video because we have discussed these factors in two lessons. Under political factors, we discussed 3 points: government policies, the political situation in the country, and government regulations. Government regulations. So, learners, is there any question? If you have any question, learners, don't shy away from asking questions. Our work is to teach and answer questions. Below this video, there is a comment section where you can post your questions. On our website, which is being displayed now on your screen, you can go sign in, then send your question. We will gladly answer all your questions. Now, I want to give you an assignment because that's what we always do. At the end of every lesson, we give assignments. That will help you revise what we have covered. I'm repeating, learners. I said it in previous lessons. At the end of every lesson and during the lesson, make sure you write notes for your revision. Okay? To revise is to review.
to go through work that has been done. You need a record of what you have learned. After you've done that, then you need to be attempting the questions at the end of every lesson. Like in this lesson, I'm going to write the questions here on the board, which I expect you to do. The questions are meant to help you cement, to reinforce what you have learned. So here is the assignment. Questions. These are questions. Question number one. Discuss the view that technological innovations have powerful influences on business operations. Let me write the question for your record. Question 1, let me write it. Discuss the view that technological innovations have powerful influences on business operations. 2. Discuss 5 benefits a business person may derive from use of the internet. Three, discuss 3 economic factors which may influence a business. 3 questions. Question 1, discuss the view that technological innovations have powerful influences on business operations. Discuss. 2, discuss 5 benefits a business person may derive from the use of the internet. Number 3, discuss 3 economic factors which may influence a business. These are things that we have discussed in these lessons. Thank you for being attentive and may God bless you. Bye-bye.
CPE students can now access top-notch lecturers anytime from anywhere. Download CPE video lectures from www.manifestedpublishers.com.
Manifested Publishers Limited is a research and teaching center that specializes in the production of learning materials and private online tuition for primary, secondary, tertiary, and university education. Sign up as a new customer at www.manifestedpublishers.com. Fill in the required credentials, full name, email, phone number, and password. Click on Sign Up. Enter the code received on your phone or email address for verification of your account, then proceed by clicking on Confirm button. Your account is ready for use and you can watch some free videos before you purchase. To get access to complete videos, use the following steps to buy. Click on View All Courses. Select the course you want to subscribe to. Click on the subject you want. Click on Buy this subject. The selected subject will be added to cart. Place or hover the cursor on cart or total amount and click on Checkout Now to proceed. Click on Lipa na M-Pesa and proceed to pay. To access your lessons, place the cursor on your name, then click on Subscriptions. To download videos for offline studying, click on Watch Offline. Download the manifested e-learning desktop application depending on your computer operating system. Install the application on your computer. Sign in on your downloaded app using the credential used during registration. Place your cursor on your name, then click on Subscriptions. Click on the subject you purchased. On the top right window, click on Download for offline viewing. Click on Go to Course. In your new window, click on the first topic, Lesson 1. Downloading process begins automatically. Thank you for choosing to study with us. For more information, you can call us on 0724 173845.
Hello viewers, welcome once again to our probability class. Like I told you, this is a topic in Form 3, and so far we have done almost all of the subunits. What we are doing is that now we are looking at further exercises in what we are calling tree diagram. We are looking at further exercises in tree diagram. So this probability, and we are looking at tree diagram. Now, my name as your host is Geoffrey Omondi, and I hope we learn together. Now, in the last class in tree diagram, I gave you a number of exercises. There's an assignment I gave. So assignment from last class. So there's an assignment I gave, and that was exercise from KLB, exercise 13.4. I gave you number 1 all the way to number 6. So I want us to try a few of them so that you can see what you did from the last class. So I want us to try number 2, and it is important I write that question so that we are able to follow it from the write-up I will be able to give from this place. Now, the question was, so I'm reading from number 2, KLB, that is page 261. The probability of a horse, A, the probability of it should be the probability that horse A, so this is not of but that, so the probability that horse A wins a race against horse B is 2/5. If the horse runs 3 races in succession, if the horse runs 3 races in succession, find the probability, find the probability that Os A, that, so we can give them the first one. Os B wins all the races. Os B wins all the races. All the races. Question B, Os A wins only one race. Os A wins only one race. C, Os A wins at least one race. Os A wins at least one race. D, Os B wins more than Os A. Os B wins more races than Os B. So those are the questions we are dealing with. The probability that Os A wins a race against Os B is 2/5. If Os A runs 3 races in succession, find the probability that Os B wins all the races. Os A wins only one race. Os A wins at least one race. Os B wins more races than Os B. So when you look at this, especially in the first race, you realize immediately we are talking of mutually exclusive events, meaning that both horses cannot win the race at the same time. If Os A wins, Os B must lose. And if Os B wins, Os A must lose. And we say that when you're talking of mutually exclusive events, then the total probability is always certain, and it is 1. So the chance of Os A or Os B winning is actually 1. Now, I want us to try and draw that tree diagram together. Now, I want us to talk of Os A winning or Os B winning. So the chance of Os A winning, we are being told Os A wins is 2/5, 2/5. Now, these are mutually exclusive events. It means that their sum should therefore be 1. So if Os A is dealing with the 2/5, it means that we need 1 minus 2/5 to get the chance for Os B. And therefore, we will have 3 out of 5, such that 2/5 plus 3 out of 5 is 1. Mutually exclusive events. So that is the first race. Now, if Os A wins the first race, we can have a second race where we'll have Os A, Os B. Or if Os B wins the first race, we'll still have a second race, Os A winning or Os B winning. Now, the chances don't change. So in this case, Os A winning again will be 2/5. Os B winning 3 out of 5. Os A winning 2 out of 5. Os B 3 out of 5. And we can create a third. Now, this is the second race. First race, second race, and now we are coming up with a third race. So in the third race, we'll again have AB, 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 and lastly AB, like that. So again here we'll have 2/5 for A and 3/5 for B. We'll have 2/5 for A and 3/5 for B. We'll have 2/5 for A in that instance and 3/5 for B. 2/5 for A and 3/5 for B. So from there, the most important thing now is to come up with what we call the outcomes. The outcomes. So to see this probably very well, I can use a different ink that will be able to give us. So this will be Os A winning OS A winning, and OS A winning. That means that OS A is winning all the races. Or we can have OS A, then OS B. So OS A winning the first race, OS A winning the second race, then OS B winning the third race. Or we can have OS A winning the first, OS B the second, OS A the third. So that one will be OS A, OS B, OS A. Or we can have OS A winning the first, OS B winning the second and the third. So that will be OS A, OS B, OS B. Or we can have OS B winning the first, OS A winning the second, and OS A winning the third. So that will be B, A. Or we can have OS B, OS A, OS B. So that will be B, A, B. Or we can have OS B winning the first and the second race, and OS A winning the third race. So that will be B, B, A. Or finally, we can have OS B winning all the races, which is B, B, B. So once you draw this, actually you've come up with what we call a tree diagram. Now, normally, even if you're not asked to draw, this will attract some marks, about 2 points, 2 marks for you having to come up with this. Because this is very important, and almost all the responses we are going to give in successive questions depend on whether you are able to draw this tree diagram correctly. So if you come up with the wrong diagram at this point, then it's almost going to be impossible for you to get these responses correct. So I want us to start with the first one. Find the probability that OS B wins all the races. So this will be the probability that OS B wins the first race, and wins the second, and wins the third, like that. Probability of OS B, B, B. So when we look at that, we know that silently there are multiplication signs in between. That is what we know. This is actually how it should be written, but this is what we write, B, B, B. So in that instance, therefore, the probability of getting the first B is 3 out of 5, times the second B is 3 out of 5, times the third B there is 3 out of 5. Now, I'm using this branch because this is the only branch that gives us an outcome of B, 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 B winning all the races. So from that point, we can go ahead and say that this will be 3 times 3 times 3, giving us 27, over 5 times 5 times 5, giving us 125. So that becomes the probability of OS B winning all the races. Now, the second part B, find the probability of OS A winning only one race. Now, you therefore have to come to the outcomes here and look at a situation where we only have A winning one race. So starting with the first one here, we have A winning all the races. Here we have A winning 2 races and B winning 1. Here we have A winning 2 and B 1. In this instance, we have A winning 1 and B 2. So this is one of the outcomes we need. Here we have B winning 1, A winning 2. Here we have B winning 2, A winning 1. So this is another response we need. And lastly, here we have B winning 2 and A winning 1. This is another response we need. So when you look at all these responses, here the outcomes, when you look at all these outcomes, you realize that A is only winning once, which is what we need here, A winning once. So we'll start with the first one here, probability of A winning the first race, followed by B winning the successive 2 races. So we'll say it will be the probability of A followed by B, B, or this other one here, which is the probability of B followed by A followed by B, or the last one, probability of B followed by B followed by A, like that. So that is what we need. So from this instance, we can look at the probability of A, which is actually probability of A, which is actually 2 over 5, times the probability of B, which is 3 out of 5, times probability of B, 3 out of 5, or means plus the probability of B, which is 3 out of 5, the probability of A, which is 2 out of 5, and the probability of B, which is 3 out of 5. Or, and or here actually means plus. The probability of B, which is 3 out of 5, multiplied by probability of B, 3 out of 5, multiplied by the probability of A, which is 2 out of 5. So we can continue and shift that information here. Now, working with the 2 over 5, 3 over 5, and 3 over 5, we can solve this by saying 2 times 3, that is 6, and 6 times 3 is actually 18. So this one will give us 18 out of 125 plus, now, if you're keen, you'll immediately notice that the values that are being multiplied in each of these three brackets are similar, meaning the value answer you get for the first bracket is actually similar for all the three. So this will also be 18 out of 125 plus finally 18 out of 125. So bringing that information up, we agreed that if the denominator are similar, then you simply add the numerators in case of addition of fractions. So the response of that will be 18 plus 18 plus 18, giving us 54, over only one of the denominators, which is 125. At this instance, I don't think there's a common divisor for the two, so that will become our answer for OS A winning only one race. So we can look at part C. OS A wins at least one race. Now, again, we have to come back to our tree diagram, where OS A wins at least one race. Now, what that means is that OS A will win 1 or 2 or 3 races. So, what does that mean? Now, when you look at this place, OS A wins at least one, you'll realize that in the first instance, OS A is winning at least one because it's winning 3. He's present here, he's present here, he's present here. OS A is still present, OS A is here, and OS A is here. So the only place where OS A doesn't win at least a race is a situation where OS B has won all the races, which is OS B, BB. Now, we agreed that these are mutually exclusive events. In other words, if we were to add all these outcomes, our answer is 1. So looking at this, and we know that where OS A is winning at least one race is all these values except BBB, we can therefore say that the probability of OS A winning at least one match, one race, that is, at least one race can be given by 1 minus the probability of OS B winning all the races, like that. So in this instance, therefore, we'll have 1 minus. Now, remember, we had already calculated OS B winning all the races, and our value was 27 out of 125. So that will be giving us 27 out of 125. Now, if we subtract this, therefore, our answer will actually be 98 out of 125. 98 out of 125. Those who are not very conversant with this, we will take LCM here, 125. Then 1 will go into 125 times 1. That will give us 125 minus. 1 will go into 125 once times 27, which is 27. 125 minus 27 is 98 out of 125. So that is how we've come with that value. So we can look at the last one. OS B wins more races than OS B wins more races. This should have been OS. Let me just check it to be clear. So OS B wins more races than OS A. OS B wins more races than OS A. So again, we'll come back to our tree diagram and find those instances where OS B has 2 or more. So when you look at this case, OS A has 1 more, OS A has 1 more, OS A has 1 more, OS B has 1 more here. So this is important, we pick it. OS A has 1 more, OS B has 1 more again, so we pick it. OS B has 1 more, so we pick it. And OS B has also 1 more. So from that instance, therefore, we can see what we need. So that is D. So that would be the probability of, the first instance is OS A, OS B, OS B. Or the probability of OS B, OS A, OS B. Or the probability of OS B, OS B, OS A, OS B, OS B, OS A, or the probability of OS B, all of it. The probability of OS B, which is probability of OS B, OS B, OS B. Now, there's something I want us to realize here immediately as we work on this. The probability of OS A winning more is the same as the probability of OS A winning only 1 race or no race at all. That is the same as the probability of OS A winning only 1 race or no race at all. Now, the probability, so we can say this is the same as the probability of OS A winning 1 race, or the probability of, so this is OS A, or the probability of OS A winning no race. So when we say probability of OS A winning 1 race, or the probability of OS A winning no race. So probability of OS A winning only 1 race, we worked it here, which gives us now 54 out of 125, or plus probability of OS A winning no race. Now, when you look at our tree diagram, the only instance where OS A is winning no race is actually where OS B is winning all the races. So that is similar to the probability of OS B winning all the races here. So, of course, you can see that OS B winning all the races, that was the first instance, is actually 27 out of 125. So when you work this one out, you get 81 out of 125. Now, there's something I want us to see. Other than what I've just shown you here, we were able to come up with this probability very well. I want us to see that this probability you are seeing here and here, at this particular point like this, probability of A, B, B, or B, A, B, or B, B, A, you can clearly see it here. So we have to be keen when we are working so that we don't work twice. Now, you realize that these questions can be very long in their responses. So you have to be keen to notice what you've already calculated so that you don't calculate it again. Again, probability of B, 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 you are able to see that it is something we have already worked on here. So you simply pick those values and put it here. Now, it is allowed. Once you've already calculated a value and you've been marked for it as correct, it is allowed you can pick that value and continue working with it without having to rework again every single value. So I want us to look at the next. I want us to look at next part of the assignment you were given. So that was number 2. I want us to straight away try number 6, which is also an assignment that was given to you in the last class. Number 6. I want us to try number 6. Now, the question in number 6 was, a man playing a game of darts, has a probability of a third of hitting a double. Has a probability of a third of hitting a double. If he throws 3 darts, if he throws 3 darts, find the probability of him hitting. Find the probability of him hitting A, 2 doubles, B, more than 1 double, and C, at least 2 doubles. So I want us to try that and see. So we will clean here so that we can try that. Now I want us to be clear that once the questions involving tree diagram, the key is the diagram itself. If you have the diagram correct, normally you find it very easy to work with that diagram. So I want us to draw the diagram. So a man is playing a game of darts and is throwing 3 darts. So I want us to see the probability. So let the probability of hitting double be represented by H, and not hitting, in other words, missing, be represented by H naught. This is read as H naught. So we are talking of this H and H naught. So let us look at the first throw. So the first throw, we can have a hit or no hit, H naught. So we can also have a second throw with a hit or no hit. Third throw, hit, no hit. Hit, no hit, like that. Here, if the first one was no hit, the second can be hit or no hit. The third here can be hit or no hit, hit or no hit. Now, we are told that to hit is a third, meaning if this is mutually exclusive, to not hit should be 2/3. So to hit is a third. Not hit, therefore, should be 2/3. So that if you add a third to 2/3, you get 1. So we will have a third and 2/3, a third, 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 2/3, like that. So those are the probabilities. So it is important, therefore, that we get the outcomes. The outcomes. Now, remember I told you earlier that this tree diagram will earn you points because it's very important part of marking your work. So if you draw it correct, it becomes very easy for you to answer what is required from you, and you will be rewarded for drawing it. There will be a point. So this one, the first outcome here will be hit, hit, hit. So H, H, H. Hit, hit, not it. So H, H, H not. Or hit, no it, hit. So H, H not, H. Or hit, not hit, not hit. So this will be H, H not, H not. Or no it, hit, hit. So this will be H not, H, H. Or no hit, no hit. So H not, H, H not. Or no hit, hit. So this will be H not, H not, H. Or no hit, no hit. So H not, H not, H. So those are the possible outcomes that we can have. So actually this is the sample space. This is what we are referring to as the sample space of this particular throwing of dirt in 3 successions. So we can continue from there. We can continue from there. And now using that tree diagram, we want to try and answer the questions that follow. We want to try and answer the questions that follow. So what is the probability that he hits 2 doubles? What is the probability that he hits 2 doubles? So this is A. So we are looking at a probability that we have 2 out of 3 hits. Remember, this particular player or man has thrown this dart 3 times. So if we ask what's the probability of 2 doubles, we are actually looking at probability of 2 hits. 2 hits. So if there are 3, only 1 should not be a hit. So we are looking at a situation where we have 1 hit not and 2 hits. So in the first case, we have all hits. Those are all doubles, 3 doubles. In the second instance, we have hit, hit, not hit. So these are 2 doubles. So this is one of the things we need. Here, we have a double, no double. So this is another thing we need. Here, we have 2 not hits, and therefore we don't need it. Here, we have 2 hits. Yes, it is another instance we need. Here, 2 not hits, we don't need it. 2 not hits, we don't need it. And here, everything was miss, not it, that way. So we are looking at those 3 instances. So we can come and say we are looking at the probability of, the first one is hit, hit, no hit. Hit, hit, no hit, like that. Or the probability of hit, no hit, hit. Hit, no hit, hit. Or the probability of the last one, no hit, hit, hit. No hit, hit, hit. Yeah, so those are the probabilities that we need from that point. Now, from here we can now work on them. The probability of hit, hit, not hit. Now, the probability of hit we have agreed is a third, and not hit is 2/3. So in this case, the probability of hit will be a third times the probability of another hit is a third times the probability of no hit is 2/3. Or means plus, and therefore probability of a hit here will be a third, no hit 2/3, hit a third. Or, which is again plus, the probability of no hit here is 2/3, hit a third, another heat a third. So these are the probabilities we are talking about. So from this instance here, we can now multiply and say we will now have 1 times 1 times 2, which is 2 out of 3 times 3 times 3, 27, plus the numerator is 2, denominator is 27, plus 2 over 27, giving us a total of 2 plus 2, 4 plus 2, 6 out of 27. Now we can simplify this further by knowing that 3 can cancel here twice, and 3 goes into 27 9 times. So that will give us 2 out of 9. So we can also look at more than one double. More than one double, number B. So number B, we are talking of more than one double. In other words, you are looking at one double, or we are looking at two doubles or more doubles. So it will be 2 heat. We are looking at 2 heat, that is 2 doubles, or 3 doubles to give us more than one double. So when we are looking at 2 doubles, we already have that. So that would be the probability of 2 doubles, or the probability of 3 doubles. Now, when we look at this, the probability of 2 doubles, we already have it in part A, and it's given by 2 over 9, or is plus probability of 3 doubles, meaning that is heat, 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 which can be given in this place like that. So that will be the probability of 3 doubles, heat, 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 like that. So from here we can still work it out and find this 2 out of 9 plus heat was a third, the probability of another heat a third, and probability of the third heat is also a third. So working with this, we can therefore have 2 out of 9 plus a third times a third times a third, which gives us 1 out of 27. So we can get LCM here, which is actually 27. 9 would go into 27 3 times. 3 times 2 would be 6, plus 27 into itself once. 1 times 1 is 1, giving us a probability of 7 out of 27. So this is a way in which you can be able to do it. So we can look at number C. Can look at number C. Let me allow me to do it here. Create a space here so that we are able to do it. We can work on it neatly like that. So this will be C. Now in C we are looking at least 2 doubles. At least 2 doubles. At least 2 doubles. Now when you say at least 2 doubles, it means that you are talking of 2 or more doubles. You are talking of 2 or more doubles. In other words, this means 2 or more doubles. But when you look at that keenly, it can also mean more than one double, because more than one double is actually 2 or more doubles. Now, when you are able to look at all this, what does it bring us back to? It means that at least 2 doubles is the same as more than one double. And therefore, in that instance, we've already calculated more than one double, and therefore our response is simply 7 out of 27. So I want us to stop there for this class today. Meanwhile, I want to add you more assignments which you can try, and we can see if we can work them out in successive classes. I want to give you an assignment, and we'll see if we will be able to work them out in successive classes. In your assignment, please work on number. So this will be exercise exercise, this will be exercise 13.4. You'll be able to work on number 9, number 10, number 11, number 12, number 13, number 14. Number 10, number 11, number 12, number 13, and number 14. Now, I want to appeal to you. Some of the times we can leave an assignment like this and you find you are not able to do it. Please feel free to go to the comment section just below this video and put your comment asking a question so that we can give you guidance on what is supposed to be done. You can also confirm with us and we give you a response. We can give you a worked example in the comment section so that you are able to work it out and follow what we have done. Otherwise, for now, I want to say goodbye. I was your host, Geoffrey Omondi. Have a nice time till we meet again. Hello viewers, my name is Geoffrey Omondi. We had a class of probability the last time and we talked about combined events. Now we had agreed earlier that there are mutually exclusive combined events and we still also have what we call independent events. Now today I want us to continue and still look at the events. Now we agreed in the first instance that when you are dealing with the events, the most important thing is to be able to come up with what we call a sample space, which was to tell us actually the total number of expected outcomes. Now, in today's class, I want us to look at another way in which we can come up with what we call a sample space. Now, that other way we are talking of today is what we are calling tree diagram. So in this class, I want us to actually look at what we call the tree diagram. So we're talking of probability, that is our topic. And we are saying that we can have a sample space. And the sample space, we had agreed we can represent it first of all by using columns or rectangles that can show us the total number of outcomes. But we can also use what we are calling a tree diagram. So today I want us to look at what we call a tree diagram. Now, consider. I want us to start from that point. Consider two coins tossed one after the other. So I want us to come up with a sample space of two coins tossed one after the other. So we can create this way and say we have the first coin. And at the same time, we can say that we have the second coin. Now, the first coin can give us only two responses, either a head or a tail. The second coin can only give us only two possible outcomes, either a head or a tail. So working with this, we can draw a sample space this way and say that the first coin can give us a head, followed by the second coin also giving us a head, or the first coin can give us a tail, followed by the second tossing giving us a head, or the first toss of the coin can give us a head, followed by the second coin or the second toss giving us a tail, or the first toss, let me just say the first coin toss so that most of us can visualize. The first coin toss can still give us a tail and the second toss give us also a tail. So looking at this, viewers, we can therefore say that our possible outcomes are now these. We can have head for the first, followed by head again, or we can have tail for followed by head, or we can have head followed by tail, or we can have tail followed by tail. So this is what we actually refer to as a sample space, a sample space, or what we also call, if we want, a probability space. So we are talking of a sample space or a probability space. We can get it this way. But we are saying that we can also get this by using another method. We can also get this by using another method, which we are also referring to as the tree diagram. So let's consider the same statement, 2 coins tossed one after the other. So looking at that, 2 coins tossed one after the other, we can look at it that way and say that in the first toss, there can be a head or a tail like that. Second toss, if you had a head in the first toss, you can still get a head or a tail. But in your first toss, probably you had a tail. So if you had a tail in the first toss, you can still have a head in the second toss or a tail in the second toss. So this will be first toss, second toss. So this will be first toss, this will be second toss. So those are the toss. Now, looking at this, we can now have several outcomes. Let's look at our outcomes. So our outcomes, first of all, there can be either a head and a head, which will be HH, or another possible outcome, if we had a head in the first place, we can follow it by a tail. So that will be head, tail. Or if we had a tail in the first row, we can now have a tail followed by a head like that. Or we can have a tail followed by a tail. So in that instance, these become our outcomes. Those become our outcomes. So we can therefore say that the possible outcomes in that case is the first one there, head, head, or followed by head, tail, or followed by tail, head, or followed lastly by tail, tail. So these are our possible outcomes. Now you can see that I've had similar outcomes in both instances. Using outcomes, getting outcomes, using these branches the way I've done. These ones resembling branches, they resemble branch of a tree. This is what we are referring to as a tree diagram. So what I've drawn here is actually the whole of this is what we are referring to as a tree diagram. So this is basically what we are referring to as a tree diagram. Now, I want us to know that tree diagrams are normally very important, especially where we are dealing with more than 2 events or more than 2 attempts. For instance, we would have a problem enumerating this in a table this way if we were talking of a third toss. But when we are talking of a third toss in a tree diagram, actually we can simply add it. So I want us to get an example. Which we can work on and see how it is. I want us to get an example. So the example we are going to work with, we are going to get it from your KLB course book. I want us to get an example from KLB course book. Yes, here is the example. So I want us to get an example. So a coin is tossed 3 times. A coin is tossed 3 times. A. Draw a diagram. Draw a diagram. Draw a diagram to show all the possible outcomes. To show all the possible outcomes. Possible outcomes. B. Find the probability. Find the probability of. Find the probability of getting 1 head, 2 heads and a tail in any order, 2 heads and a tail in any order, 3 2 heads and a tail in that order, 2 heads and a tail in that order. We can clean here so that we can continue. Four, 3 heads. 4, 3 heads. 3 heads. 5, at least 1 head. At least 1 head. 6, no head. No head. So I want us to work on those for now, and we see how it's going to work. So solution. So we are told that the first thing that we're supposed to work on is to draw a tree diagram. So we have to draw that diagram, and it's simple. We'll start by that. So we are told the toss is 3 times. So our first toss will give us only 2 options, either a head or a tail. A head or a tail. Second toss. So second toss, if we had a head, we can still get a head and a tail. But in our second toss, it's also possible that the first toss was a tail. So we can still get a head or a tail in the second toss. The third toss, therefore, so this is third toss, we can still get a head and a tail. A head and a tail. A head and a tail. A head and a tail, like that. Now, I want to explain this because it is very important. When you're dealing with this, I want you to know that this is the first toss. In the first toss, our sample space only has 2 things. Either we are getting a head or a tail. In our second toss, we are now working from 2 bases. In the second toss, we are agreeing that in the first instance, probably we had a head. But if we had a head, we can still have a head or a tail. And it doesn't depend on what we had in the first instance. In other words, if we had a head in the first instance and we have a head now, we can go ahead and say that we now have 2 heads. Still, we can have a tail in the second throw, but at the same time we had a head in the first throw. So I want us to know that as we move on, we keep on branching. We keep on branching such that every other thing that comes from this first head, let me just show, though we will still erase this so that you are able to see. You have to see that all these things that are under this dotted line actually happen, and they're not dependent on the first head happening, but they are the descendants of the first head, such that from this we can only have head, tail, head if we actually had a head in the first instance. We can still have head, head, tail only if our first row was a head. So I want us to make it very clear, therefore, that as we move, our options keep on increasing, such that I want to illustrate simply from a simple family tree. A simple family tree. This is just illustration. If in your family there is a grandfather, or let's say a father. So father can give birth to two children, a boy and a girl. Still, a boy can give birth to two children, a boy and a girl. And the girl can also give birth to two children, a boy and a girl. Now, the boy of the boy here can still give birth to two children, a boy and a girl, and this girl can still have a boy and a girl, and this one can still have a boy and a girl, and this one also a boy and a girl. Now, when you look at all this, if we were, for example, to pick this girl here, although this girl has so many cousins, but how many generations are we talking of? 1, 2, 3. This is a grandchild to the father. Just like if we were to pick this boy here. In other words, whether this boy is a boy or a girl does not depend on anything. It can be a boy or a girl. But at the same time, is only existing. We can only talk of a boy in this family tree if the first grandfather here was a boy. So you are able to see, in this case, we can be able to talk of the first, like that. We can be able to talk of the second generation, like that. We can also be able to talk of the third generation, like that. So we are talking of progressive. So if these were coins, this would be our first toss, our second toss, our third toss. So in this instance, you can see we have our first toss, our second toss, and our third toss. So we were using that to illustrate, but I want to see, we are talking of something like this. The more we continue moving, the more our sample space and the chances increase, the more our probabilities increase. So I want us to continue in that spirit. Let me clean this. Let me clean that way, so we can continue. So having worked with this, we can now write here our outcomes. So our outcomes. So this is the sample space actually we are talking about, outcomes. So the first outcome can be, you will have a head, and a head in that order. So head, head, head. So I want you to notice that if you throw the coin 3 times and you have a head and a head and a head, it means that you cannot have any other combination. All your responses are heads. Or another outcome possibility can be the first throw being a head, the second toss being a head. I want us to see how we are moving ahead, and a tail. The third one being a tail. Or we can have a head, a tail, a head. That will be head, tail, head. Or we can have head, tail, tail. So that is head, tail, tail. Or we can have tail, head, head. So that will be tail, head, head. Or we can have tail, head, tail. Tail, head, tail. Or we can have tail, 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 head. Tail, tail, head. Or lastly, we can have tail, tail, tail. Tail, tail, tail. So these are the possible outcomes that we can be talking of. These are the possible outcomes that we can be talking of. So I want you to realize immediately that the first question that was required of you was to draw a tree diagram to show all the possible outcomes. Now, normally it is important to write the probabilities in each case. Now, I want us to know that these are independent activities, such that in the first instance, for you to get a head or a tail, the chance is half-half. So the probability there is a half, and the probability is a half. In your second throw, if you are throwing a coin, there is no relationship with the first throw. So probability remains to be a half, 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 and a half. So all the chances are a half, meaning in every instance there is equal chance of getting a head and equal chance of getting a tail. That's why we are saying that half. So I want us to move ahead and start finding the second part, number B. So this is our sample space. This is our sample space. Our sample space is HHH, HHT, HTH, HTT, THH, THT, TTH, TTT. So that is our sample space, or what we also call probability space. That is our sample space, or what we also call a probability space. So I want us to go ahead and try to answer the questions that follow. So one head. What is the probability of getting one head? Now, probability of getting one head, we now have to look at our sample space here and see outcomes that only have one head. For instance, in the first outcome here, we have 3 heads. Here, 2 heads. 2 heads, 1 head. So we need this. We can tick it. We need it because it has 1 head. We have 2 heads. We have 1 head. So we need this as well. We also have 1 head here. These are now 3 tails, so no head. So these are the 3 possible outcomes we are interested in. Those are the 3 possible outcomes we are interested in. So what will we say? In this instance, therefore, we can say that the probability of getting only 1 head, probability of only one head can be given by the probability of head, tail, tail. So that will be head, tail, tail. Or it can be tail, head, tail. Probability of tail, head, tail. Or it can also be given by the probability of tail, tail, head. Probability of tail, tail, head. So those are the 3 probabilities. Now, there's something I want us to remember. For example, if we say head, tail, tail, what it means, we are looking at the probability of head and tail and tail. In other words, it's the probability of head times the probability of tail times the probability of tail, in that order. So probability of head, tail, tail, this one, this is the probability. So this is a half and a half and a half. So that will therefore be given by a half for the head, followed by a half. I'm using times because this is and, followed by a half. Now, you have to know, along a branch, normally multiply. Even if you are having problem remembering that, just know along a branch we are multiplying. Now, or means plus. Or means plus. Probability of tail, head, tail is this one. So tail is a half. times head a half times tail a half. Or the third one, the probability of tail head, this one. So the probability of getting a tail here is a half. And the probability of getting another tail, a half. And the probability of getting a head in this case is a half. So you can work with that way. So you can go ahead and say that a half times a half times a half, this will be 1 times 1 times 1, which is 1 over 2 times 2 times 2, which is 8, plus, now these are similar brackets, so this will be 1 over 8 plus also 1 over 8. We agreed that whenever you are adding and the denominators are similar, simply add the numerator and pick one of the denominator. So in this case we have 8, then 1 plus 1 is 3 out of 8. So 3 out of 8 become the probability of getting only one head. The probability of getting only one head. So the second part, 2 heads and a tail in any order. 2 heads and a tail in any order. So in this instance, you will now say that 2 heads and a tail in any order. So we are looking in a situation where there are 2 heads. So this is one of them. Another 2 heads, we have 2 heads here, yes. Do we have 2 heads here? No. Do we have 2 heads here? Yes. We have a tail and 2 heads. Do we have 2 heads here? No. Do we have 2 heads here? No. And do we have 2 heads here? No. So it's only these 3 instances. Now, so this can therefore be given by probability of head, tail, tail, or the probability of can also be given by the probability of tail, head. Let's see. The first one was head, tail. Yes. Head, tail, head. Head, tail, head. Or we can also talk of probability of tail, head. Tail, head. So those are the 3 probabilities we can be talking of. So again, we can work on them. Head, tail, a half. So that will be a half times a half times a half. Or the probability of head, tail, head. To get head, there will be a half. Tail, a half again. Another head, a half. Or the probability of tail, head. They are all a half. So that will be a half times another half times another a half. So in that instance, we will solve this first bracket, which will give us 1 out of 8, or is the same as plus 1 out of 8, or is again the same as plus 1 out of 8, giving us a total of 3 out of 8. So that is how we can solve the second part. That is 2 heads and a tail in any order. 2 heads and a tail in any order. Now, viewers, because this is our question and our space is running out here, how I wish we could still erase here, because we are still using both of these parts, the equation and the tree diagram, to answer what we are dealing with. So you will allow me to clean here again so that we continue working. Now, meanwhile, it is important that I note that only one head was 3 out of 8, and 2 heads and a tail in any order was also 3 out of 8. So those are the answers we've gotten so far. So 2 heads and a tail in that order. So in this instance, we are now restricted. There is some order. In other words, we want 2 heads and a tail, and they must follow each other. So we must have a head and a tail, and no any other order. So we have to look here and see where we have 2 heads first and then a tail later. Yes, so this will become the head, and then followed by a tail. So that will be the third the third one. So we'll be looking at the probability of head, head, tail, like that. So looking at that, head, the first head, the probability is a half. And we have to get a head again. The probability is a half. And we have to get a tail, which is also a half. So working on this, we can get 1 times 1 times 1, which is 1, over 2 times 2 times 2, which is 8. So therefore, the probability of head, head, tail is actually 1 out of 8. So we can go ahead and look at 3 heads, probability of 3 heads, probability of 3 heads. This was number 4. This is now number we are now in number 4. That was number 3. That was number 3. So we have number 4. So number 4 is now 3 heads. 3 heads. In other words, you are looking at probability of head, 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 like that. 3 heads. And when we look at here, there's only one instance where we have 3 heads, which is this. So we'll say the probability of getting a head is a half, probability of getting another head is a half, and probability of getting a third head is a half. So when we multiply this across, we end up with 1 out of 8. 1 out of 8. Finally, we can go ahead and look at least 1 head. So this will be number 5, at least 1 head. Now, I want us to think. When we say at least 1 head, we are therefore looking at 1, 2, or 3 heads. Now, when we look at this situation, we have them. Head, head, head. So we have at least 1 head here. The second situation, head, head, tail. So we have at least 1 head. The third situation, head, tail, head. So we have at least 1 head. The fourth one, head, tail, tail. We have at least 1 head. The fifth one, tail, head, head. So we have at least 1 head. Here there's a head, here there's a head. So there's only one place where we don't have a head, and it is tail, tail, tail. Now, we agreed that these are now mutually exclusive events. In other words, if you have head, 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 you cannot at the same time have head, head, tail. Mutually exclusive outcomes when you look at the general outcomes here. Now, looking at this, therefore, we know that if we add all these probabilities, our answer is 1. Therefore, we can reason, because if we want at least 1 head, what we will do is we'll get the probability of head, 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 or the probability of head, head, tail, or so we will be adding all these probabilities up to here and fail to add the last one. Now, in that case, therefore, we can therefore decide that if we know that if we were to add everything, our answer is 1, therefore, we can say that at least 1 head, we can simply say this is 1 minus the probability of tail, 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 which will now be simpler. We'll only take this one, remove from 1, which will give us the total of everything remaining up. So this will be 1 minus tail is a half times another half times another half. So this will be 1 minus, when we work out a half times a half times a half is actually 1 out of 8, giving us what we call 7 out of 8. So that is how we can work on at least 1 head. That is how we can work on at least 1 head. But I want to challenge you. Challenge. Can you use the alternative? Use alternative way of adding all the other outcomes except tail, tail, tail. So I'm giving you that challenge. Can you try adding these ones and see if you'll end up with the same probability? And don't add tail, 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 so that we see if we end up with the same probability. Lastly, no head. The probability of no head. Now, when you look at that, the probability of no head means we have in all the three instances, we have tails. So it therefore means we are looking at the probability of tail, tail, tail. So the probability of no head is therefore the same as the probability of tail, 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 which can be given by a half times a half times a half, giving us 1/8. So that is how we can work on that when we are looking at the probabilities. Now, you see, when you are dealing with tree diagrams, viewers, it is important that you do a lot of practice. Now, these questions can be long, and therefore normally it's important that when we leave an assignment behind, you make sure that you attempt and then you look at the comment section just below this video and put your comment there by asking questions so that we can respond in good time and so that it can help you. Otherwise, I want to tell you that questions like this normally attract a lot of points in exam, 10 points to be precise, questions like this, and therefore it's very important to be keen with them. Otherwise, I want to leave an assignment behind that you will attempt. So the assignment is this. Exercise, this is KLB. So this is the assignment. KLB exercise 13.4. I want to leave number 1, number 2, number 3, number 4, number 5, and number 6. So this is the last part actually of this topic, but we will continue to do further examples in the next class. My name is Geoffrey Mondi. See you in the next class.
Hello learner, my name is Dickens Mgalo and today we want to talk about salts. Let's start by looking at the objectives. At the end of this topic, you should be able to define a salt. Then number 2, you should be able to state and describe types of salts. You are going to see we have around 4 types of salts. And then number 3, you should be able to identify both soluble and insoluble salts. Then number 4, by the end of this topic, you should be able to state methods of preparing both soluble and insoluble salts. And then number 5, you should be able to define the terms saturated solution, crystallization, neutralization, as well as precipitation. And then number 6, you should be able to write ionic equations. We shall see we are going to write ionic equations using precipitation reactions. And then number 7, you should be able to state the effect of heat on salts. We shall see salts behave differently when they are decomposed by heat. And then lastly, by the end of this topic, you should be able to state uses of salts. Having said that, let us start by knowing the meaning of the word salt. So, learner, what is the meaning of this word salt? So, a salt can be defined as follows. So, a salt can be defined as a compound that is formed when hydrogen ions from an acid are wholly or partially replaced by a positive ion. For example, if you look at this equation here, if you react, for example, a zinc metal with hydrochloric acid, you'll realize that zinc will react and the product will be zinc chloride and hydrogen gas. So, learner, we are saying that this hydrogen ion in the acid has been replaced by the positive ion, and the positive ion is zinc. As a result, the product formed is called zinc chloride, and this zinc chloride is what we are calling a salt. So, from the definition, we are saying a salt is a compound formed when this hydrogen ion from the acid is replaced by this positive ion or a metal. So, as a result, the product that we are forming is called zinc chloride, and that is our salt. So, let's now move on by looking at types of salt. So we have said a salt is defined as a compound formed when hydrogen ions from an acid are wholly or partially replaced by a positive ion. So a positive ion is also called a cation, which can be a metal, like for example, the example we have used above there. So next up is I want us to look at types of salts. Let's look at types of salts. We have 4 types of salts, like I've said earlier. So types of salts. So we start by mentioning them. So the first type we call acid salt. Then number 2, we have normal salt. Then number 3, we have a basic salt. And then number 4, we have a double salt. So Lana, we are saying we have 4 types of salts, namely acid, normal, basic, and double salt. So let us see what is the meaning of each type of salt. So we are going to start with an acid salt. So what is the meaning of the word acid salt? So an acid salt, from the word acid, in Form 1 we learned about acids and said all acids contain a hydrogen ion. So we are saying the distinguishing property of an acid salt is what? All acid salts, their distinction property is that all of them contain a replaceable hydrogen ion. So how do we identify an acid salt? An acid salt is identified by the presence of hydrogen ion. So we are saying an acid salt can be defined as a salt that contains a replaceable hydrogen ion. So let's look at examples. For example, we have a salt such as sodium hydrogen carbonate. From the formula, Lana, we can see that we have a hydrogen ion. So this hydrogen ion is the one that will make this salt to be called an acid salt, because it has this hydrogen ion that will give it the acidic properties. We have another example is sodium hydrogen sulfate. So this hydrogen ion that is present in this salt is the one that will give it the acidic property. So we are saying, Lana, that an acid salt is one that contains a replaceable hydrogen ion. As you can see from these 2 examples, we have a hydrogen ion in the sodium hydrogen sulfate as well as a hydrogen ion in the sodium hydrogen carbonate. Therefore, these 2, we call them acid salts. The second type of salt